Welcome back to Sleep Nova. Sit back, relax, and don't forget to comment where you're watching from down below. It's amazing seeing people all around the world supporting my small channel. Now, enjoy the show. Imagine yourself lying on a soft meadow on a clear night, far from any city lights. The air is cool against your skin, carrying the faint scent of grass. Above you, the sky is a black, velvet dome sprinkled with countless stars. The Milky Way arches overhead, a pale river of starlight. In this quiet moment, you feel deeply connected to the cosmos. The same space that stretches between those stars also surrounds you. A gentle breeze brushes your cheek. It moves through the night and through the space around you, here on Earth. As you gaze upward in comfortable silence, more and more pinpoints of light emerge, a glittering mosaic against eternity. You realize that when you look at these stars, you are literally looking back in time. Their light has traveled for hundreds or thousands of years to reach your eyes tonight. Some of those stars may have already lived out their lives and vanished, yet their glow still journeys onward through the dark to greet you here and now. You feel the solid earth beneath you and know that it too is suspended in that great darkness, a small, warm world afloat in an ocean of space. Yet you are not afraid. The darkness above feels inviting, almost comforting, like a vast shelter. The endless sky, rather than making you feel insignificant, fills you with peace and wonder. In the silence, you sense with gentle certainty that you are a part of this grand universe. The starlight that falls on your skin, the space that cradles your body, the photons entering your eyes, all of it binds you to the cosmos. You close your eyes for a moment. Behind your eyelids, the after-image of the stars dances in little sparkles. You take a slow breath in, and as you exhale, you let any tension flow out of you and into the vastness around. There is room for all of it to dissolve. There is room for everything in space. The universe is so wide and forgiving that your own cares begin to feel lighter, quieter, soothed by the infinite calm. Now, in that spirit of tranquility, let us embark on a journey into space itself. The space around us, the space within us, the space that is the foundation of all things. We begin where we are, in stillness, in the darkness, in the quiet. The night is profound and motionless. Above, the stars shine as tiny islands of light in a vast sea of black. Space stretches endlessly between and beyond them. This scene feels serene and timeless. Nothing stirs. No breeze now, no sound at all, only a gentle hush, the natural silence of a cosmos at rest. It is as though time itself has paused. You can almost feel the depth of this silence, a soft, velvety silence that blankets everything. The emptiness around you seems to embrace you with a subtle, invisible presence. For ages, we humans looked at the night sky and found it peaceful, but also mysterious. What is this blackness between the stars? We used to think it was nothing, an empty void, an infinite vacancy. People spoke of the void and the vacuum as if it were a true nothingness. We even doubted whether a true vacuum could exist at all. Ancient philosophers imagined that space must be filled with something. Aristotle believed nature abhorred a vacuum. Later, scientists in the 19th century hypothesized an invisible ether filling space to carry light across the emptiness. But experiments showed no such ether was needed. Light moves through empty space itself. This was a remarkable discovery. The void can carry light, as if emptiness has its own solidity. It hinted even then that space is not simply an inert backdrop. For a long time, though, the common view of space remained that it was a passive emptiness, a gargantuan container in which the objects of the universe, planets, stars, galaxies, are scattered. We pictured space as a stage and the stars as actors upon it, with no real influence from the stage itself. If you removed all the actors, the stage would just sit there, blank and silent. We imagined that if you took all matter away, you'd be left with pure nothing, an absolute void, infinite and eternal. Over time, however, our understanding evolved dramatically. We learned that space is far from nothing. That black backdrop, that stillness and silence, is deceptive. Space has properties, a structure, a dynamic of its own. In the past century, every new discovery has reinforced this truth. Space can bend. Space can carry light and soundless vibrations. Space can stretch. It can even boil at the tiniest scales, flickering with unseen energy. What we once thought of as an empty stage is more like a participant in the cosmic play. Tonight, as you float in this quiet moment, the darkness around you is not dead or inert. It is the very fabric that connects and supports all things. Let's explore this step by step, gently and thoroughly, starting with one of the most profound revelations, that space and gravity are intimately linked. Beneath you, the Earth's mass is pulling you down, or rather, it's warping the space under your body so that down is the direction you naturally fall. Above you, the moon is held in its orbit by the shape of space around Earth. This understanding comes from Einstein's great insight in the early 20th century. Gravity is not a mysterious force acting across empty distance, but a feature of space and time itself. Mass and energy tell space how to curve, and the curvature of space tells objects how to move. In essence, matter sculpts space, creating valleys and hills in the fabric of space-time, and objects simply roll along those curves. What you feel as gravity, the weight on your back as you lie in the grass, or the pressure of your body against your bed, is actually space itself pushing you downward, guiding you along the curved lines it has formed around the Earth. To visualize this, imagine space as a vast elastic sheet spread out under the stars. If you place a heavy object on that sheet, say a bowling ball to represent a star or planet, the sheet will dimple, sagging inward around the weight. Now, if you roll a marble nearby, representing a smaller object like a planet, the marble will no longer travel in a straight line. It will spiral around the bowling ball, caught in the curve. In reality, Earth orbits the Sun because the Sun's mass curves the space around it, creating a sort of well that Earth is rolling around. Earth thinks it's moving in a straight line, and indeed it is, locally, but space itself is curved, so straight for Earth is actually a loop around the Sun. There is no gravitational force pulling Earth in a literal sense. Earth is simply following the path allowed by the curved space, like a ball rolling around a curved bowl. All planets, all moons, all orbiting bodies are doing the same. They are not tethered by invisible strings. They are skating along the contoured roads of space. Right now, as you lie still, you are held to the ground by this phenomenon. The mass of the Earth has curved space under you such that down points toward Earth's center. Your body presses into the ground because space is telling you to move that way. The ground pushes back and holds you up. Space does this quietly and continuously. You feel the effect as weight, but really, it is space-time gently urging you along a curved path that the solid Earth prevents you from taking. If Earth were not here, that curvature would extend unopposed. You would fall freely along a path through space toward where Earth's center was. All of this happens with no sound and no drama. Space does its work quietly. In essence, what we experience as gravity is the shape of space around us. Matter, like the Earth beneath you, tells space-time how to curve, and that curved space-time tells matter how to move. Gravity is not something that reaches out through space. Gravity is space. The stillness around you, in fact, is full of these invisible curves and subtle depressions wherever there is mass nearby. If you could see the geometry of space, You'd see gentle indentations around every tree, for even small objects curve space a tiny bit. Deeper wells around the mountains, and a huge well under your body, reaching to Earth's core. But space does its job so smoothly that you don't notice anything odd. You just stay attached to Earth as naturally as a leaf rests on the ground. This idea also means that when a massive object moves, it can create ripples in the fabric of space. Much like a stone dropped in a pond sends out waves on the water. Imagine two massive stars circling each other rapidly, or better yet, two black holes, extremely dense objects, spiraling together. They disturb the space-time around them so much that waves of curvature spread outwards. These are called gravitational waves, literal ripples of space traveling at the speed of light, washing through the cosmos. For a long time, we weren't sure these ripples really existed, but in recent years, scientists built instruments so sensitive that they could feel space-time tremble. When two distant black holes collided and merged, in a galaxy billions of light years away, our detectors on Earth quivered ever so slightly. Space itself stretched and squashed by a tiny amount, far smaller than an atom, as the gravitational wave passed through. We heard the universe whisper through space-time. It was as if the stillness briefly sang a faint melody. Think about that. We built a device that can sense the movement of space from events that happened billions of years ago in far-off corners of the universe. When we detected those waves, it confirmed that space-time is not just an abstract idea. It's a real, physical fabric that can carry vibrations. Space can ring like a cosmic bell, even though we cannot hear it with our ears. In September 2015, when those two black holes merged, the fabric of space around Earth oscillated subtly, and our instruments recorded the telltale chirp. It was a triumph of human curiosity and a profound validation of the idea that emptiness has structure. The silence of space isn't absolute. If you have the right ears, space can indeed be heard. What an elegant picture, space as an ever-present elastic medium, carrying both the weight of stars and the whispers of their collisions. In summary, matter tells space-time how to curve, and space-time tells matter how to move. Gravity is not a pull through some void. It is the gentle guidance of objects along the contours of space-time. All of this, the Earth holding you, the Moon orbiting Earth, Earth orbiting the Sun orbiting our galaxy's center, is happening because space itself is shaped by mass and energy. Our everyday experience of weight is actually our intimate connection to the shape of space. So, from the stillness of space arises what seems to be a force, but space has more surprises. We've talked about space's shape. Let's now consider its unity with time. When Einstein described gravity as the curvature of space-time, he was saying something equally profound about time. That time is woven into the very fabric of space. Out in this quiet night, space and time seem separate. You can point in directions, you feel time passing. But experiments and theories show that they are inextricably linked. If you move fast or sit in a strong gravitational field, your experience of time changes relative to someone elsewhere. Space and time together form a four-dimensional weave, and gravity is the bending of that weave. Consider that the passage of time on the surface of Earth is slightly slower than time far out in space, because Earth's mass not only curves space, but also warps time. A clock on a mountain, where gravity is a tad weaker, ticks a little faster than a clock at sea level. Likewise, a clock on a fast-moving spaceship will tick slower than one on Earth. This isn't science fiction. We've measured it with precise atomic clocks. Even the GPS satellites in orbit must correct for time running faster up there. Weaker gravity, so faster time, compared to ground. Otherwise, their positioning would drift. What we find is that space and time adjust together. If space is squeezed or stretched, time is also altered. They are two aspects of a single entity, space-time. Think of space-time as a fabric with both spatial threads and temporal threads interwoven. You cannot disturb one without disturbing the other. When the sun's mass curves space-time, not only does space get warped, but time runs a bit slower near the sun compared to far away. An astronaut near a massive object ages a bit less quickly than one floating in weaker gravity. This is called gravitational time dilation. Similarly, if you travel at a speed close to light, time for you will slow relative to those you left behind. There is a famous thought experiment. Imagine twins, and one goes on a near light-speed journey to a distant star while the other stays on Earth. If the traveling twin returns after what she feels was perhaps a few years, she might find decades or more have passed on Earth. Her clock and body experience time more slowly due to her rapid motion through space-time. This isn't just a story, it's a real effect, verified by many experiments with particles and precise clocks. All of this tells us that space and time are not the separate, absolute backgrounds we once assumed. There is no universal time ticking the same for everyone, regardless of their state of motion or gravity. Instead, every observer has their own passage of time, depending on how they move through space and how space is curved where they are. Two people reunited after following different paths through space-time will have experienced different durations. What an astonishing reality. Time itself is elastic, flexible, personal. So here, under the stars, when you consider a moment of time and a stretch of space, realize they are part of one four-dimensional continuum. Here and now are bound together. You cannot point to a location in space without also specifying the moment in time. Everything that happens in space-time. The unity of space and time frames all experience. Right now, your heartbeat and the position of the moon both have coordinates in space-time, and gravity is the geometry of that space-time linking the two. Space and time are fused like two threads of a single fabric. Move fast through space, and you skew your passage through time. Stand in strong gravity, and time for you will run a bit slower than for someone far away. This interplay might sound complex, but think of it this way. Space alone isn't the full stage, and time alone isn't either. Rather, events unfold in space-time. If you try to separate them, you lose part of the picture. Even this peaceful moment has a space-time coordinate. You, here and now, under the night sky. As you lie there, time flows a tad differently than it would if you were orbiting the Earth or sitting on the moon, because the gravity and motion differ. The differences are small but real. Space-time enfolds you, ensuring that your now and here are connected into the grand tapestry of cause and effect that makes up reality. The important takeaway is, space and time are one fabric, and gravity is the bending of that fabric. The stillness you feel includes both space and time quietly doing their work. There is a timeless quality to this night because space and time together create that sensation. In this eternal present, you are embraced by space-time, which gently carries you along the stream of time while holding you in the structure of space. We have journeyed outward to see that what we thought was emptiness actually shapes the cosmos, and journeyed inward to see time intertwined with space. But the rabbit hole goes deeper. We must now explore the nature of space at the smallest scales, far smaller than a grain of sand, smaller than an atom, where an entirely new picture emerges. One might expect that if you zoom into space closely enough, you would eventually find absolute stillness and uniformity, perhaps even true nothingness. But our current understanding, through the lens of quantum physics, says otherwise. On extremely tiny scales, space is anything but smooth and still. It is frothing and fluctuating, buzzing with ephemeral activity. Physicist John Wheeler poetically called this the quantum foam. To grasp this, imagine shrinking yourself down beyond the microscopic, beyond the level of atoms, to a realm billions of times smaller. If you could stand there, if the word stand even makes sense at that scale, the tranquil emptiness you perceive at our scale would vanish. Instead, you'd witness space seething with spontaneous eruptions of energy. Particles would blink in and out of existence like fleeting sparks. Distances and directions would blur as uncertainty reigns. In quantum physics, even what we call a perfect vacuum, completely devoid of matter and cooled down to remove all heat, is not truly empty. There is a fundamental jitter that cannot be removed. This is because the laws of quantum mechanics tell us that certain pairs of physical properties, like energy and time, or position and momentum, cannot both be known with infinite precision. There is a built-in uncertainty, and because of it, a vacuum cannot have exactly zero energy for all time. If it did, we'd know both its energy, zero, and that it stays that way, no fluctuation, forbidden by quantum rules. Instead, the vacuum seethes with what we call zero-point energy, a baseline, irreducible energy. What does this mean in practice? It means that empty space is constantly witnessing tiny particles flickering into being from nothing, then vanishing almost immediately. These are often called virtual particles. For example, a particle of light, a photon, might momentarily pop into existence, along with a counterpart, perhaps an electron-positron pair, borrowing energy from the vacuum for a brief instant. They appear, exist ever so briefly, and then annihilate each other, paying back the energy. All of this happens on timescales and distances so small we normally have no way to detect it directly. But it's happening everywhere, all the time. The space around you, between you and the next breath of air, between the electrons and nuclei in your body, between the Earth and Moon, is awash in these quantum fluctuations. On the scale of the unimaginably small, much smaller than an atom's nucleus, space-time would not look like a smooth sheet. It would look like a turbulent ocean surface in a storm, full of random waves, bubbles, and wrinkles, hence quantum foam. One moment, a bit of space might have slightly higher energy, sprouting a virtual particle-antiparticle pair. An instant later they collide and disappear, leaving a slight vibration of energy that then might spawn another pair elsewhere. Space at that level is a riot of spontaneous activity, an invisible, high-speed flickering that averages out to a seemingly smooth, stable whole at larger scales. We've even observed tangible effects of this quantum vacuum. If you place two metal plates extremely close together in a vacuum, just a few nanometers apart, they will experience a tiny force pushing them toward each other. This is the Casimir effect, and it happens because the quantum foam between the plates is slightly different from the foam outside. Certain virtual particle wavelengths can't exist in the narrow gap, so there is a tiny imbalance, fewer electromagnetic modes between the plates than outside. The result is a subtle pressure that nudges the plates together. In essence, the empty space between the plates has less quantum activity than the space outside, causing them to be pushed inward by the more energetic fluctuations outside. It's a small force. You'd need sensitive instruments to measure it, but it's real and has been observed. It's as if the vacuum between the plates is not nothing. It exerts a gentle push. This is a direct demonstration that empty space is never truly empty. The vacuum is alive with energy and possibility. In particle physics experiments, we also see clues of the quantum vacuum. For instance, empty space can briefly lend energy for the creation of particle pairs that affect processes like nuclear decay. The very fact that protons and neutrons inside atomic nuclei can change forms via quantum fluctuations involving ghostly particles is tied to vacuum activity. Even the stability of atoms and the patterns of atomic spectra bear the imprint of zero-point energy. So, as incredible as it sounds, the takeaway is that emptiness is not truly empty. It's an active medium. The stillness we perceive is actually a frenetic dance at microscopic scales. The vacuum is constantly borrowing energy here, giving it back there, in accordance with quantum uncertainty, Put poetically, even when nature whispers hush, there remains an undercurrent of subtle noise, a quiet fizz of existence and annihilation on the tiniest scales. The concept of nothingness has been forever changed by this discovery. Empty space is a cauldron of potential, a field of fields, a stage for ceaseless miniature drama. If you were to shrink down into that realm, as a moment's imagination, since physically we cannot, you might see space flicker with tiny flashes, the foam that Wheeler described. It wouldn't be placid or uniform, it would be dynamic and random. The notion of a sharply defined point in space might lose meaning, blurred by these fluctuations. We sometimes say space-time becomes quantum foam at the Planck length, about 1035 meters, far smaller than any particle. At that scale, the smooth geometry of space-time breaks down into something probabilistic and fluctuating. Let's take a different kind of imaginative journey to appreciate this. Inward, into the fabric of matter and space inside you. Envision shrinking yourself, as we did under the stars, but now not in distance outwards, rather in size. You diminish down past the scale of dust mites, past cells and their nuclei, past even viruses and DNA molecules. Now you are smaller than an atom. Ahead of you floats a single atom of carbon from your body. It appears enormous from your current perspective. You approach it like a tiny spaceship nearing a planet. The atom consists of a blurry sphere, that is the cloud of electrons orbiting the nucleus. As you draw closer, this cloud is mostly transparent. You realize the electrons are tiny points moving so fast, they form a diffuse shell. You dive through this wispy shell of electron probability and find yourself in the interior of the atom. Suddenly, you are in what seems like a vast cavern. It feels eerily similar to drifting in space between stars. It is dark and almost empty. You might even see a faint glow of energy fluctuations around. The quantum foam flickers here too. For a moment, it's as if you're floating in a miniature version of outer space, a huge volume with almost nothing in it. Ahead, after some distance, you see a tiny but brilliant object, the atomic nucleus. You move toward it. What before was the immense atom is now mostly behind you. All that's left ahead is that nucleus, a cluster of protons and neutrons tightly clumped. It's small, incredibly small. If the whole atom were a cathedral, the nucleus would be like a single grain of sand at its center, and yet, that grain of sand holds almost all the mass. You come right up to the nucleus. It's made of particles bound together, busy with internal motions, but you cannot linger. At this scale, forces are intense. You decide to zoom back out. When you return to human scale, you carry with you a profound appreciation. Inside every atom in your body, between the electrons and the nucleus, there are enormous stretches of empty space. In fact, nearly all of the volume of each atom is empty. The solidity of your body, of the ground, of this meadow, it's an illusion created by the electromagnetic forces of electrons repelling each other at those tiny distances. No two atoms ever truly touch in a physical sense. Their electron clouds push against each other first. Matter is a scaffold built on emptiness. It is astonishing. All the solid things we see around us are about 99% empty space. If one could magically remove all the empty space within the atoms of your body, compressing the electrons into the nuclei, you would shrink to a microscopic speck, smaller than a pinhead, yet you'd weigh the same as you do now. By some estimates, if we removed all the empty space from all the atoms of all humans on Earth, the entire human race could fit into a volume the size of a sugar cube. It sounds impossible, but it's because atoms are so vast compared to their tiny nuclei. Nature itself offers a demonstration. In neutron stars, the remnants of large stars, gravity crushes atoms so hard that electrons and protons merge, eliminating that atomic emptiness. A single teaspoon of neutron star material can weigh billions of tons. That's how much stuff was hiding in the empty space of atoms. When that space is removed, matter's true density shows. Fortunately, here on Earth, our matter stays spacious, our atoms intact with their generous voids inside. Take a moment to let that sink in. Solidity is an illusion. When we say an object, a rock, a chair, your own body, is solid, we're talking about the collective sense of touch that arises from trillions of atoms whose electrons resist being pushed into the empty space of one another. It is like a lattice of charged particles, and their mutual repulsion gives structure and firmness. But the structure is mostly empty space. We and the world we live in are made of a whole lot of nothing. It's a humbling realization. You are a being composed almost entirely of voids, shaped by forces and energy into the form you call you. In a very literal way, you are a small universe of particles orbiting each other in vast fields of emptiness. Now we have explored the microscopic character of space, the quantum foam and the atomic void. We've seen that even when matter is present, it's built on a framework of emptiness, and even when nothing is present, space is still far from idle or empty. The calm void of night harbors deep activity at tiny scales and comprises the majority of the volume of any solid thing. Space pervades every corner of existence. It is above us in the cosmos and within us in each atom. Let's step back out to the cosmic scale again. We've marveled at gravity and quantum foam and the space within atoms. But what about the shape of the universe as a whole? Does this infinite darkness go on forever? Does it curve back on itself like the surface of a planet? These questions have intrigued humanity for as long as we've looked up and wondered. Is space infinite, or is there some kind of boundary or loop? With modern science, we have attempted to measure the geometry of the universe. The answer isn't fully in, but so far it appears that on the larger scales we can observe, space is extremely flat and likely unbounded. By flat, we mean it follows the rules of Euclidean geometry, the sums of angles in triangles, etc., as far as we can see. If space had a noticeable curvature, we would detect distortions in the patterns of galaxies or the light from the early universe. The results? All measurements indicate that space is extraordinarily flat on the biggest scales. If there is curvature, it is so gentle that our observable universe, a sphere of about 93 billion light-years in diameter, doesn't reveal it. To use an analogy, Earth appears flat to someone walking a few miles because it's so large that the curvature isn't obvious at that scale. Similarly, the universe might be curved in some way, but on the scale we can survey, it looks effectively flat. What does flatness imply for the extent of space? It suggests that space could be infinite, extending forever in all directions, or it could be finite, but without boundary, like how the 2D surface of a sphere is finite area, yet has no edge, except extended to three-dimensional space. If space has positive curvature, like a 3D sphere, it would be finite in volume, and if you traveled far enough in one direction, you might eventually end up where you started, just as an ant crawling on a basketball eventually loops around. If space has negative curvature, like a saddle shape, it would be infinite and spread out with a different geometry. A flat universe, the simplest case, can be infinite and just go on and on. Current data lean toward flatness and therefore possibly infinitude, or a curvature radius so immense that for all intents and purposes it is infinite to us. From what we can tell, there is no edge to space, no wall where space ends. If it is finite and curved back on itself, going in a straight line could, in theory, bring you back to your starting point after an almost inconceivably long journey. We have looked for evidence of light wrapping around the universe, like seeing the same galaxies repeated from opposite directions, which could happen if space were closed and not too large. But we haven't found any such patterns. If the universe is finite and closed, it's far larger than the volume we can see. If it's infinite and open, it just has no end. In either case, there's no boundary that says, beyond here, there is nothing. Space, as far as we know, either goes on forever or loops back on itself. The observable part, what we can see, is certainly finite, but that's only due to the limited age of the universe and the finite speed of light. Beyond that observable horizon, we expect there is more universe, probably much more. We can summarize our findings here. The large-scale universe appears flat and unbounded. Precision measurements of the cosmic microwave background, the afterglow of the Big Bang, by satellites and telescopes have narrowed any possible curvature to be extremely slight. So, space is remarkably flat as best we can tell. It might truly be infinite. It might wrap around on a scale so huge we haven't detected it. Either way, for our observable domain, Euclid's geometry holds to a high degree. Parallel light beams do not meet, and the angles of a huge triangle drawn by, say, beams of light spanning billions of light years seem to add up to 180 degrees. This is a clue that the cosmos, on the whole, is not shaped like a sharp sphere or saddle within our view. If it is spherical, the sphere is enormous beyond imagination. If it is saddle-like, the curvature is so subtle that we haven't discerned it yet. In our contemplative journey, lying here under the night sky, it's awe-inspiring to realize we've been able to figure this out at all. By observing distant galaxies and the patterns in the microwave background, humanity has effectively used the universe itself as a giant ruler and protractor. We map the distribution of galaxies and notice that on large scales, they form a sort of cosmic web, filaments of clusters and superclusters surrounding huge, nearly empty voids. Those voids, expanses tens of millions of light years across with hardly any galaxies, highlight again how dominant space is over matter. Matter forms a delicate lace, and space is the vast expanse between its threads. The cosmic web shows that even on the grandest scale of clusters of galaxies, emptiness stretches out between them, making up the bulk of existence. Indeed, when astronomers survey the cosmos, they see that galaxies are not evenly spread. They line up in filaments and walls, with enormous voids between. Those voids are truly empty regions, aside from perhaps the stray hydrogen atom here or there. Some voids span hundreds of millions of light years with essentially no galaxies inside. Think about that. Such a volume is mind-bogglingly large, and yet nearly completely devoid of stars, planets, or light. Just tenuous gas and darkness. Those cosmic voids are, in a sense, pure space on the largest scale, a testament to how predominant emptiness is. The luminous matter, galaxies, clusters, outlines like scaffolding on the tapestry of space, but the vast gulfs between that scaffolding are space itself, pristine and quiet. Now, our understanding of space wouldn't be complete without touching on one of the greatest mysteries of the cosmos today, the fact that the universe's expansion is speeding up. We mentioned earlier that the universe is expanding like a rising loaf of bread, carrying raisins, galaxies, apart. You might expect, intuitively, that this expansion would slow down over time. After all, gravity is pulling galaxies toward each other. Indeed, for a long while after the Big Bang, the expansion did slow as gravity reined it in. But to astronomers' astonishment, in the last few billion years, the expansion has begun to accelerate. Galaxies are flying apart faster and faster. There is something in space, some form of energy tied to the vacuum itself, that is pushing the universe outward. We call this strange phenomenon dark energy. The name is just a placeholder, really, a label for our ignorance. It was discovered in the late 1990s when two independent teams observed distant exploding stars, supernovae, and found them dimmer, and thus farther, than expected. It was as if, over the billions of years their light traveled, the space between us and those supernovae had stretched more than it would have in a decelerating universe. At first, this result was met with surprise and a bit of skepticism. Could the expansion be accelerating? That was contrary to everything we thought. Even Einstein, long before, had considered a static, or at most slowing universe. But one by one, other evidence accumulated. Detailed maps of the cosmic microwave background and surveys of galaxy clustering both pointed to the same conclusion. Some kind of repulsive effect is at work on cosmic scales. By the early 2000s, the verdict was clear. The expansion of the universe is speeding up. So what is dark energy? In short, we don't know. It appears to behave like an intrinsic property of space. Like each cubic meter of vacuum has a certain tiny amount of energy that doesn't dilute even as the universe expands. If that's true, then as space expands, you get more vacuum, and thus more of this energy, causing expansion to push even harder, a runaway effect, though fortunately a very gradual runaway. Roughly 2/3 of the universe's total energy content today seems to be this dark energy. Only about 1/3 is in matter, mostly dark matter, plus a few percent normal matter like atoms. That means most of what's out there is this mysterious energy of empty space. It's dark because we can't see it or touch it. It doesn't emit light. And it's energy in the sense that it does work on the universe. It's causing space to swell. We sometimes describe dark energy as a negative pressure or an anti-gravity effect of the vacuum. It's as if emptiness itself has a springiness, a tendency to expand. Every bit of empty space gently pushes outward on itself. The effect is extremely weak on small scales. It's completely overwhelmed by local gravity or even the forces binding galaxies. But on the vast scale where gravity's pull has been growing weaker as galaxies get farther apart, eventually this subtle pressure took over and started accelerating the expansion again. The concept of dark energy reminds us how much we still don't know. It humbles us. We see its effects, yet the cause remains elusive. It could be something fundamental about space that we have yet to understand, perhaps related to that quantum foam energy we talked about. Those straightforward calculations of vacuum energy don't match the observed dark energy. That's a huge puzzle in physics. It could be a new field or fluid pervading the cosmos, or an adjustment needed in our theory of gravity at large scales. We gave it a name, but naming is not understanding. Dark energy is truly a question mark at the heart of cosmology. In essence, what we know is this: empty space isn't just inert nothing. It has this property that is making the universe fly apart faster and faster. The same emptiness between galaxies carries an unknown energy that currently drives the fate of the entire universe. Far from being an irrelevant void, space, through dark energy, will determine how the cosmos evolves trillions of years into the future. To put it succinctly, something latent in empty space, call it dark energy, is accelerating the expansion. The void has a sort of built-in push. This discovery is as dramatic as when we first learned space can bend. It tells us that space has a mind of its own, so to speak, a propensity not only to warp when mass is present, but to grow even where mass is absent. It's as though emptiness has a gentle heartbeat, steadily pumping the universe larger. So now we have seen space from two extreme perspectives: the microscopic, roiling with quantum fluctuations, and the cosmic, swelling with dark energy. We've also seen space permeating matter in atoms. It is clear that space is not a passive backdrop. It's dynamic and rich. Let's recap our journey so far in simpler terms. Gravity taught us that space is flexible. It can bend, fold, and ripple. Relativity taught us that space and time are united. Quantum physics taught us that space is restless at small scales. It's never truly empty. Modern cosmology taught us that space can expand and carries a mysterious energy in its very form. And everyday life and atomic physics taught us that even seemingly solid matter is mostly space inside. Now, with these insights, consider what space really is. It's not empty. It's the very medium of existence. Space is the canvas on which the masterpiece of the night sky is painted, and also the paint and pigments in that masterpiece. It is the medium through which light travels, and also an actor that shapes the story. By bending light, for example, as in gravitational lensing, where space curves around a massive galaxy cluster and bends the light of more distant galaxies into arcs. Space is the connector between distant objects, the silence that allows a conversation via light or gravity to happen across cosmic distances. Space is the stage on which all cosmic drama unfolds, and yet it is also an actor, shaping the plot with its curves and expansions. It is the ocean on which galaxies sail and the gentle tide that carries them apart. Space is a teacher of humility. It shows us that even what seems empty can hold unimaginable power and significance. It reminds us that absence can be potent, that silence can speak volumes. The stillness of space, which once seemed like nothingness, in fact contains the code that dictates the evolution of the entire universe. When we consider the scale of space and how much of everything is made of it, we might feel small, but there is comfort in it too. Space is a comfort in its constancy. It's been here since the beginning and will be here long after the end of all things. When we feel overwhelmed by our day, we can look up and remember how vast and enduring the universe is. Our worries shrink in the face of that perspective, not to trivialize them, but to soothe us with the knowledge that we're part of something much larger and older, where many troubles have come and gone under the eternal sky. Even our ignorance, like the mystery of dark energy, is a kind of tribute to how subtle and profound space is. It's astonishing to realize that only a century ago, we didn't know any of this. We thought the Milky Way was the entire universe, and we believed space was just an empty void that played little role. Now we've learned so much, that the universe is expanding, that space and time bend, that there are countless other galaxies, that space can erupt with virtual particles and drive cosmic acceleration. Each discovery has only deepened the wonder. Knowing that space can ripple and boil and propel galaxies doesn't take away the magic of the night sky. It adds layers of awe to it. The more we comprehend, the more we appreciate how extraordinary it all is. Finally, let's ponder one more speculation that stretches our imagination to the limit. The possibility that our universe's space is not the only space. Could it be that beyond the observable universe, or in dimensions or contexts we cannot see, there are other universes, other expanses of space-time, disconnected from ours? In other words, a multiverse. This idea is highly speculative, yet many scientists consider it plausible given certain interpretations of cosmology and quantum theory. One scenario arises from cosmic inflation, the extremely rapid expansion that likely occurred fractions of a second after the Big Bang. Inflation might not have ended everywhere at once. It could be bubbling continuously, even today, in distant realms beyond our horizon. Each bubble that inflation drops out would become its own universe with possibly different properties. Our universe would be one bubble among potentially countless others in a frothing metacosmos. To visualize this, imagine stepping outside our universe, a mind-bending thought, and looking at a larger sphere of reality. You might see an eternally expanding space like boiling water, with bubbles forming here and there. Each bubble is a universe, perhaps with its own galaxies and laws of physics. Ours is just one bubble that happened to inflate and then slow down, allowing stars and galaxies to form. Some bubbles might remain forever separate, carried away by relentless inflation in between. Others might occasionally collide, potentially leaving subtle imprints. People have even searched our sky for patterns that could be from a collision with another universe bubble, though none has been confirmed. In this view, reality is far grander than what we can see, a multiverse of universes. Another multiverse concept comes from quantum mechanics, the many worlds idea, where every quantum event splits reality into multiple branches. In that interpretation, there is a vast ensemble of parallel outcomes, parallel universes coexisting in a larger quantum reality. If true, There might be another version of you in a parallel world where some decision or event went differently. This is a different flavor of multiverse, more about layers of reality stacking on the same space rather than separate bubbles of space. But it underscores how space might be part of a much larger tapestry. Whether through cosmic inflation or quantum many worlds or other ideas, like perhaps a cyclic universe that periodically resets, the multiverse remains a hypothesis. We have no direct evidence of other universes. We may never have. It is a mind-expanding possibility, essentially suggesting that what we used to call the universe, meaning everything, might be just a tiny piece of an even vaster existence. If it's true, it's the ultimate Copernican revolution. Not only are we not the center of the universe, but our universe might not be the only one of its kind. Just one bubble in an endless foam. Such a concept can be daunting, but it can also be oddly comforting. It would mean creation is endlessly fertile. That reality tries every possibility, that somewhere, everything that can happen does happen. It also could provide an answer to that question of why our universe has the conditions it does, why the constants of nature are fine-tuned for life. If there are countless universes with varying conditions, we naturally find ourselves in one of the rare universes that is compatible with observers like us. In a multiverse, our hospitable cosmos isn't a 1 in a billion fluke so much as an inevitability among infinite tries. We should stress that the multiverse is still speculative. It's an idea, albeit one that arises from serious physics theories, but we have yet to find a way to test or observe it. It remains a tantalizing possibility on the fringes of our understanding. Whether true or not, just contemplating it broadens our perspective even further. It tells us that space, that fundamental thing we've been exploring, might come in an endless variety of forms across different universes. Perhaps some universes have more dimensions of space, or different kinds of particles, or maybe no matter at all, just endless empty space-time, expanding or contracting. The possibilities are endless. Even if the multiverse remains unproven, thinking about it does one certain good. It underscores just how precious our particular universe is. We have this vast cosmos to explore and understand, full of wonders like those we've discussed tonight. We might be essentially alone, with no other universes ever reachable, or we might be one among billions. Either way, our task and our joy is to know our universe as deeply as we can and find our meaning within it. Now, let us gently return to where we began, to the simple stillness of the night and the feeling of space around us. After journeying through curved space-time and quantum foam, across the cosmos and into the atom, we come back to ourselves, lying here under the sky, whether literally or in our mind's eye, quiet, at peace, and maybe a little wiser. The night is still as it was, but we are not the same. The darkness holds more meaning now. We can sense, behind the silence, the faint echoes of all those phenomena we've talked about. The whisper of space-time, the hum of the quantum vacuum, the faint pressure of dark energy, the quiet spaciousness within our very cells. The stillness around us resonates with the knowledge that it is not an empty stillness at all, but full of structure and story. Space is not empty. It's imbued with the fabric of existence. It connects everything to everything else. In this darkness, the light from distant stars travels. The space allows it to move at the fastest speed possible. The gravity of the Earth extends through space to tug on the moon. Fields, like the electromagnetic field, permeate space and allow radio waves, visible light, X-rays, all forms of light to propagate. Invisible geomagnetic fields from Earth reach out into space around you right now. Space truly is the medium in which all things exist, and through which all interactions occur. If it were somehow removed, all those interactions would vanish, and nothing could happen or even be. Consider some of the roles of space we've encountered. Space is the canvas on which galaxies paint their grand designs, and also the weaver that curves and folds itself to create gravity's effect. Space is the nurturer of structure. Its quantum fluctuations seeded galaxies, and its expanses gave them room to grow. Space is the arena of all history. Every event that has ever happened, from the birth of a star to the firing of a neuron in your brain, took place in space-time. Space is the ultimate connector. When you touch a loved one's hand, it's the space and electromagnetic force fields in that space, between the atoms of your hand and theirs, that communicates the pressure and warmth. Space is a teacher. It teaches us that what appears empty can be full, that absence can have presence. It is a guardian of the universe's secrets, hiding dark energy within itself, keeping the ultimate fate of the cosmos in its hands. And space will be the stage for the universe's far future. Looking trillions of years ahead, one can envision a time when space will be virtually all that remains. As the eons pass, galaxies outside our local group will drift farther and farther away, eventually vanishing beyond the horizon, their light stretched into oblivion by the expanding space. The night sky will grow emptier as distant stars disappear from view. Trillions of years from now, even the stars in our own galaxy will exhaust their fuel. One by one, they will wink out, leaving behind faint embers, white dwarfs, neutron stars, and black holes. These remnants will gradually cool and evaporate, in the case of black holes, via Hawking radiation, over an incomprehensible span of time. The universe will continue to expand and cool toward a state of almost complete darkness. In that far future, no new stars are born. No bright galaxies light up the sky. What remains is largely space itself. Vast, cold, nearly empty, studded only sparsely with subatomic particles and the fading whisper of photons from long ago starlight. And yet, through it all, space endures. The same fabric of space-time that was there at the fiery birth of the cosmos will still be there in that silent twilight eons hence. The stage persists even after the actors have left. Perhaps that will be the final chapter of our universe. An ever-expanding dark volume of nearly pure space, quietly extending into eternity. Perhaps, someday, quantum fluctuations within that nothingness might seed a new Big Bang, a new universe, a speculation in some cyclic cosmologies. But either way, the legacy of space is that it is the last cosmic witness. When all else has come and gone, space will still be here, silent and waiting, as it was in the beginning. Space is, in a sense, the alpha and omega of the universe, present at the start, shaping everything in between, and remaining at the end. Now, back to this moment. The night is deep and beautiful. The quiet around you, this gentle void, is the same entity we've been contemplating in all those extraordinary ways. Let that sink in. The empty air and space enfolding you right now carries the heritage of the entire cosmos. It carries the gravity that holds you to Earth. It carries the starlight that reaches your eyes. It carries the potential for future worlds and the echo of the very birth of the universe, a faint whisper of microwave background that bathes all of space, even now, at about 2.7 degrees above absolute zero, giving the night a slight warmth. This space around you is part of the same continuum that bends around a black hole and expands between galaxies and buzzes with vacuum energy. You are deeply connected to the universe through space. You always have been. It's impossible to be truly isolated because the fabric of space links you to the furthest galaxy and the smallest atom. When you look at the stars or simply breathe the night air, that connection only becomes more apparent. You are a child of space, born from stardust that coalesced in space, sustained every second by the oxygen and photons traveling through space. And ultimately, when you return to dust, your particles will drift in space again. Bask in that realization. You belong. You belong here in the universe, and it belongs in you. The boundary between you and out there is not a wall, but a porous membrane constantly exchanging matter and energy. You inhale the atmosphere, drawing in molecules that might once have been exhaled by ancient trees or dinosaurs, and ultimately originated in cosmic processes. You exhale, and your breath's atoms eventually mix into the sky and beyond. In a physical sense, you are never separate from the universe. You are always in communion with it. Take another slow, gentle breath. Feel the cool air fill your lungs, and know that even that simple act is an interaction with space. As the air spreads in your lungs, it's essentially molecules finding room in the internal space of your body, delivering oxygen to your cells across microscopic gaps. As you breathe out, you're releasing carbon dioxide that will travel through the atmosphere, maybe feed plants, maybe one day waft into the upper sky and beyond. Through you, the earth and space are linked. Now, you have permission to let go of all these thoughts if you wish. You don't need to actively think about curvature or quantum foam or dark energy anymore tonight. The knowledge is there, settled gently in the back of your mind, enriching the way you feel the night. You can simply relax in the feeling of it, the feeling of being part of this vast, ongoing cosmos. Above, the stars continue to shine, distant and silent. Around, the darkness remains calm and embracing. You might sense in your own body a mirror of the cosmos, the rise and fall of your chest like the expansion of space, the circulation of blood like galaxies drifting in their clusters, the neural flashes in your brain like tiny starbursts. In the stillness, you can almost feel the subtle humming connection between your life and the wider universe. You are safe. You are weightless and free. The quiet of space enfolds you like a warm blanket. Feel how the whole universe supports you in this moment. The ground beneath you, the air around you, the sky above. You belong here. You are part of all this. There is nothing you need to do right now except be. Just exist. Just rest. Inhale the stillness. Exhale any worry. Let yourself float on the calm of the cosmic ocean. You are safe. You are embraced by existence. You are at peace. No matter where you go, you carry this home of space with you. It was there at the first moment of your life. It sustains you each day, and it will remain long after we are gone. The stillness that surrounds you is the same stillness that cradled the young universe and that will hold the final stars as they wink out. You are truly home in this stillness. It is the cradle of everything. All the understanding we've gained about gravity, time, quantum foam, expansion, and so on, leads to a simple, profound truth. Space is not empty. It is everything. It is the foundation and framework of existence, and you are not separate from it. You are one with it. An expression of the universe, a part of space becomes self-aware. When you gaze at the night, the universe is gazing back at itself through your eyes. So rest now, gently, in the embrace of space. Feel the deep peace of knowing that you are held by the same darkness that carries the stars. The infinite extends around you, quiet and caring. Let go of any remaining tension. Let it fall into the vast well of calm that is space. Let your thoughts drift like gentle clouds across the sky of your mind. No need to chase them. They can float away into the darkness, leaving you calm and clear. You are safe. You are weightless. You are free. The endless silent universe enfolds you, and you belong to it. You are a part of it all, and it is a part of you. In this profound unity, you can release all fears and rest. The night is very quiet now. Around you, the earth sleeps, and the cosmos watches in patient silence. Feel your heartbeat slowing, peaceful. A tiny clock kept by space-time within you. Feel your breaths becoming soft and rhythmic, the same rhythm that pervades all of nature. There is no rush. Time flows at its own gentle pace. Space provides limitless room for your dreams to unfold. You are home in the universe. You are never alone. The space that fills your room, your lungs, and your heart connects you to the furthest galaxy and to the beginning of time. In this knowledge, you can truly rest. All is tranquil. All is as it should be. Stillness. The stars shine. The galaxy slowly turns. The universe breathes in and out on timescales far beyond comprehension. And here, in this quiet moment, you breathe softly, in unison with the cosmos. The stillness of space is within you and around you. Let it lull you into a deep and gentle sleep. Feel yourself drifting, weightless, on a calm, cosmic sea. There is nothing to fear in this dark. It is the same darkness that gave birth to the first dawn. There is everything to love in this silence. It carries the echoes of creation and the promise of eternity. You are safe. You are connected. You are at peace. Sink deeper now into the comforting dark. The universe holds you like a parent cradling a child. The ground beneath you, the sky above, all is one with you. Your mind is quiet, tracing the outlines of these truths with a final, drowsy sense of awe. What remains is not calculation or analysis, but a simple reverence for existence. In the grand sanctuary of space, you close your eyes, your breathing slow and steady. The boundary between yourself and the night dissolves. You are the universe, and the universe is you, a wave returning to the ocean of space. Rest now in that knowledge. Rest in the arms of the cosmos. Feel the profound stillness, the gentle, omnipresent support of space beneath you, holding you up as it has held up worlds and suns and galaxies. Let that stillness fill you. There is nothing more to do, no more striving needed. Just be. Just let yourself go, like a leaf floating on a vast dark pond, carried by the calm currents. Space will watch over you. It has always watched over everything. Your mind is calm. Your body is relaxed. The stars continue their silent vigil overhead, and you drift closer to sleep, carried by the same silence that spans the light years. The feeling of space, that stillness, that openness, that gentle cradle of all things is all around you, and it soaks into your very bones. In this moment, you are that stillness. There is no separation. Quietly, the universe whispers you a lullaby in the language of silence. It says, "You are home. You are home." Let yourself drift in this infinite peace, stillness, silence, space. The journey is complete. The knowledge is within you. The stillness is everything. You are a child of the cosmos, and the cosmos is kind. Feel its love in the quiet of the night. Space is not empty. Space is everything. And you, your atoms, your mind, your life, you are part of that everything. You always have been and always will be. In the great dark between the stars, there is comfort and belonging. In the stillness here, there is the embrace of the infinite. Be at peace, dear traveler of the universe. You are home in the stars and the night. The space around you is your space. The silence around you is your silence. Nothing separates you from the whole. You are safe. You are loved. You are one with the deep, eternal stillness of space. Rest now in that eternal stillness. Let the quiet carry you into restful sleep, as gently as a mother rocks a baby, as naturally as night becomes dawn. The universe holds you. Stillness, silence, sleep. Good night, child of space. The cosmos within and around you watches over you, now and always. Stillness. I invite you into the silence, a pregnant hush between moments, into the vast and boundless calm that lies behind all things. I am space, and I surround you completely. I am the darkness and depth between stars, sparkling like diamonds, the stillness between breaths, the expanse that holds every atom and every galaxy. In this moment of stillness, you ask, what am I? Long before you understood what I am, you looked up and filled me with stories. Often you gave me names and personalities: Nut, Uranus, Shu, the Heavens Father and Earth Mother, trying to understand my nature through myth and story. You sensed there was something powerful about the emptiness and silence above, something worthy of reverence. In ancient times, you imagined the sky as a dome overhead, painted with countless stars, a firmament just beyond reach. Earth, you thought, sat at the center of a small, orderly cosmos, and I was merely a backdrop, an upturned bowl decorated with lights. But over centuries, your perspective evolved. You discovered that the Earth is not the center, but a planet circling one star among billions. You learned that the stars are not holes in a dome, but distant suns scattered through a vast and boundless abyss. The more you learned, the more your conception of me transformed. From a finite vault above your head to an infinite expanse with depth and structure. What once was a comforting, closed sky became an endless ocean of space stretching in all directions without center or edge. Emptiness, it turned out, was not empty at all, but rich with secrets. I am not a simple void. I am more like a canvas, invisible yet ever present, holding the artwork of reality. Without me, there could be no separation between things, no here or there, no before or after. If I truly were nothingness, everything would collapse together with nowhere to be. It is I who give reality its form and scale. Some have called me a cosmic ocean, and indeed, I roll on endlessly. Galaxies can be thought of as boats, or even tiny leaves carried on my currents. Gravity is the tide that pulls and shapes, and light is the beacon that travels my waves. You, on your planet, are like a sailor on a small ship, just beginning to venture from the shore and grasp the true scale of this ocean. The ancients launched their imaginations into my depths with myths. You launch rockets and let telescopes sail my waters of space, discovering new horizons that only reveal greater and greater oceans beyond. Time itself started with my birth. Asking what came before is like asking what lies north of the North Pole. There was no before me, for without space and time, before and after do not exist. In the beginning, I was compact beyond imagining. In a flash of creation, I was born alongside time and energy. Back then, I was small, hot, and filled with potential. In fact, in my first split second, I likely underwent an extraordinary expansion, an inflation, swelling far faster than the speed of light, because no object moved through space. Space itself grew, and smoothing out the cosmos. What started as microscopic became cosmic almost instantaneously. After that initial surge, my expansion settled down to a more stately pace. As I expanded and cooled, the matter and energy within me began to coalesce. Tiny quantum tremors, random fluctuations in the fabric of reality, were stretched out with me. Those minuscule irregularities, mere whispers in the silence, would become the seeds of all structure. The galaxies and clusters and cosmic web of today trace their origins to those first faint ripples. For a long time, you humans saw me as static emptiness, but then you discovered my deeper nature. You learned that I can bend, curve, and ripple. Massive objects like stars and planets do not just reside in space, they deform it. Picture a heavy ball placed on a flexible sheet. The sheet stretches and curves around the ball. Similarly, when a star sits within me, I wrap around it, curving in response to its mass. This curvature is what you feel as gravity, though you once imagined gravity as an invisible force acting at a distance. It was a revolution in thought to realize this. No longer was gravity a mysterious pull through empty void. Instead, gravity became the shape of space itself. Mass and energy tell me how to curve. In turn, I tell objects how to move. A planet orbiting a star is like a marble rolling around the rim of a bowl, my bowl, gently curved by the star's presence. Planets circle not because of ropes or invisible strings, but because they are following the curves of space that mass creates. In this way, I cradle the sun and earth in an embrace of geometry, allowing worlds to orbit with no physical tether except the structure of space. Space and time are inseparable in this dance. I am space, but I am entwined with time, my eternal partner. Together, we form space-time, a unified fabric where every here is woven with a now. Under the weight of a star or planet, not only do I bend, but time itself slows down. When I curve strongly, time itself also slows and bends. We both warp together, threads of one cosmic cloth. Even on Earth, this effect is present. Time runs slightly faster high in the mountains than at sea level, where gravity is a bit stronger, and a clock on a fast-moving spacecraft ticks a bit slower than one on the ground. These differences are tiny in everyday life, but they become measurable with precise instruments, and they prove that time is not separate and absolute, but intertwined with space and motion. Picture a clock deep in a gravity well, near a massive planet. It ticks more slowly than a clock far above. If you lived your life on a mountaintop, you'd age a few microseconds more over a lifetime than your twin at sea level. If you flew in a fast rocket, your time would pass slightly differently than that of those you left behind. This isn't just fantasy. It's measured fact, evidence of how profoundly connected space and time are. Consider the extreme, a black hole. Here, space curves into a deep, steep well. If the mass of a star is crammed into a tiny volume, it bends space-time so intensely that not even light can escape the grip. A black hole is a place where space and time themselves break from ordinary rules. If you ventured towards such a black hole, you would hardly notice the exact moment you crossed its invisible boundary, the event horizon. But outside observers would see you slow and fade, never quite seeming to fall in. Space around you would funnel inward. Every path, every direction would lead down to the center. Escape becomes impossible because beyond that horizon, all routes point deeper in. At that center, the singularity, our known physics falters. It may be a point of infinite density, a place of zero volume where my curvature grows without bound. Or perhaps quantum effects soften the blow. We do not yet know. But certainly, whatever falls in does not return. In that hidden heart of a black hole, space itself flows inward like a rushing stream, carrying matter with it. These cosmic traps are like caves in my fabric, unseen directly, but sensed by their intense gravity. And when two black holes collide and merge, they send tremors through me, ringing the universe with their final merger. Yes, I can ripple like the surface of a pond. When massive objects move violently, stars exploding asymmetrically, or black holes orbiting each other, they create waves in space-time itself. These are gravitational waves, faint ripples that race across the universe at the speed of light. I carry these vibrations as a silent echo of distant cataclysms. For a long time, they were merely predicted, but not heard. Then, in recent years, you built instruments so sensitive that they could feel these tremors. In a quiet laboratory, lasers in long vacuum tunnels detected the subtle stretching and squeezing of space from two black holes colliding 1 billion light-years away. It was a whisper, a tiny chirp in the data, yet it spoke volumes, confirming that when the universe moves, I truly ring. Those waves traveled at light speed, bringing news of events far across the cosmos. That speed, the speed of light, is a kind of built-in limit to how quickly anything can move through me. It is the pace at which cause and effect unfold at maximum efficiency in the fabric of space-time. No material object or message can exceed it, for doing so would violate the order of time and space. Light and gravitational waves race along at this ultimate speed, taking years or millennia to cross the gulfs between stars and galaxies. Even this universal speed limit testifies to the unity of space and time. It emerges from their geometry, a manifestation of how distances and durations are interwoven. Look around now at your immediate surroundings. The distance between you and the walls of your room, the gap between trees outside, the gulf between Earth and Moon. It's all me. I am the separation and the connection. I give everything a place and a distance. I allow here to be distinct from there, and in doing so, I grant form to existence. Without my dimensions and distances, all would condense into a single point. Nothing could be distinguished or defined. It is space that allows two objects or two people to be distinct, and space that they close when they come together. When you reach out to hold someone dear, you diminish the space between you until, in a hug, it nearly disappears. In that instant, you feel unity. When you step back, space gently opens up again, and you remain two, connected but separate. Thus, space enables both the coming together and the being apart. It is the possibility of closeness and the reality of individuality intertwined. From the small span of your room, let's journey outward. Beyond the ceiling, beyond the clouds, beyond the reach of breathable air, there, a mere 100 kilometers above you, lies the threshold of outer space. At that height, the sky turns black, even in daytime, and the stars shine unblinking. Small satellites and a great orbiting station circle Earth in that tenuous realm, falling around the planet in my grip. Farther out, the Moon orbits at about 384,000 kilometers away, separated by a vast void that once seemed impossibly large until your rockets bridged it. Yet the gap between Earth and Moon is tiny compared to the distance between planets. Tens of millions of kilometers of mostly empty space separate Earth and Mars at their closest approach. Between the outer planets, the distances swell to hundreds of millions or billions of kilometers. Stretches so great, your mind struggles to fathom them. Still, even those immense gulfs are mere pockets within the solar system. Beyond the outer planets, I extend outward for trillions more kilometers before you even reach the next star. Our Sun's nearest stellar neighbor, Proxima Centauri, is about 4.2 light-years away, roughly 40 trillion kilometers. If you could ride a beam of light, it would still take over 4 years to journey there. At that distance, the Sun is just an exceptionally bright star in the sky, and Earth is utterly invisible, lost in the solar glare. Indeed, journeying outward, by the time you reached even the nearest star beyond the Sun, our world would be completely undetectable to your eyes. At 100 light-years away, the entire solar system is but a faint point of light, indistinguishable with the naked eye. At 1,000,000 light-years, even the Sun's light merges anonymously into the background of the Milky Way. This illustrates how alone your fragile world is, and how much space dominates the cosmos. As we continue outward, the pattern of stars becomes a structure. The Milky Way, your home galaxy, a spiral disk of stars, gas and dust, about 100,000 light-years across. There are hundreds upon hundreds of billions of stars in it, clustered in its bright center and strewn along its spiral arms. Our Sun is one such star, about 27,000 light-years from the galactic center, surrounded by the vast interstellar medium of gas and dust within me. The stars in the Milky Way are separated by light-years of space, enormous gulfs that dwarf even those between planets. Yet on the scale of a galaxy, those distances are small, like grains of sand separated by centimeters in a vast beach. Galaxies themselves, however, are separated by even greater distances, millions of light-years. As we leave the Milky Way, the galaxy itself becomes just a pale, luminous band from afar. We enter intergalactic space, perhaps the purest emptiness my nature offers, with only a few atoms per cubic meter, and photons from distant galaxies passing through. Here, in these immense stretches between galaxies, one could travel for millions of years and not encounter a single star or planet, only the occasional whiff of hydrogen or a fleeting subatomic particle. In this darkness, the nearest galaxies appear as small, faint smudges of light. The Andromeda Galaxy, about 2.5 million light-years away, is one such smudge, a spiral galaxy larger than our own, slowly drifting closer under our mutual gravity. One day, 4 billion years from now, our Milky Way will collide and merge with Andromeda, reshaping the night sky over eons. What now appears as a diffuse blur in Earth's sky will one day, for far future eyes, spread across the firmament as our galaxies dance together and become one. Even these colossal events unfold within me, guided by my geometry and gravity's pull. Filaments and sheets of matter create an interconnected web that forms the large-scale structure of the universe. The further out you go, the more you see that galaxies are not isolated. They gather in clusters and chains, arranged along gossamer threads of gas and invisible, dark matter, outlining enormous voids where few galaxies dwell. Our Milky Way, along with the local group of nearby galaxies, is part of a larger collection, a cluster, which in turn lies on the outskirts of the Virgo supercluster, which itself is part of an even larger flow of galaxies called Laniakea. This hierarchy continues up to the greatest scales, a cosmic web, hundreds of millions of light-years in extent, with galaxies clustered along filaments and tremendous voids, empty dark reaches tens of millions of light-years across, separating them. Early in my life, matter was nearly uniformly spread, but not perfectly. Tiny variations, those quantum whispers from my birth, meant some regions had slightly higher density. Over billions upon billions of years, gravity magnified those slight differences. Regions a bit denser grew into filaments and clusters, drawing in surrounding matter, while regions slightly emptier became vast voids. Within the luminous filaments of this web, countless dramas unfold. Dense clouds of gas and dust, nurseries tucked in my corners, collapse under gravity and ignite new stars into brilliance. I cradle these newborn suns in vast glowing nebulae, their light painting the surrounding clouds in ethereal pinks and blues. Around many stars, disks of material coalesce into planets. Some of those worlds may one day know life gazing up at their skies, as you do, wondering at the expanse beyond. I have seen stars live for millions or billions of years, transmuting simple elements into heavier ones in their hot cores. I have seen giant stars exhaust their fuel in tremendous supernova explosions, momentarily outshining whole galaxies. In those fiery deaths, they scatter their enriched guts, elements like carbon, iron, gold, far and wide through my expanse. Those atoms drift through interstellar space, eventually mixing into new clouds that form new generations of stars and planets. In this way, I facilitate a great cosmic cycle of birth, death, and rebirth. Nothing in me truly stays inert. Even in what seems like emptiness, gravity is pulling, radiation is traveling, and the seeds of future worlds are being sown. Astronomers on your world have peered deep into space and witnessed my handiwork. With their telescopes, they have captured towering pillars of gas in distant nebulae where new stars spark to life. The pillars of creation in the Eagle Nebula, for instance. They have seen the delicate, expanding rings of supernova remnants, such as the Crab Nebula, the graceful shell of an exploded star, still glowing in colorful filaments. They have marveled at spiral galaxies, swirling cities of hundreds upon billions of stars, stretching across the cosmos in grand patterns, and at colliding galaxies warping into bizarre, enchanting shapes. To human eyes, these images are breathtaking art. To me, they are simply the natural expression of matter and gravity playing out over time. All these sights reveal that even what appears chaotic or empty holds artistry. The universe paints with gravity and light upon the canvas of space, creating structures of spectacular grandeur within me. We currently estimate that there are around 2 trillion galaxies in the observable cosmos. Each of those galaxies contains billions upon billions of stars. And beyond the observable, there could be more universe, perhaps infinitely more, harboring uncountable galaxies we will never see. Yet even as matter organizes into this immense cosmic web, most of the volume of the universe is, frankly, empty. The great voids between filaments contain only the faintest traces of gas, a few atoms per cubic meter, and the feeble glow of distant galaxies stretched thin. If you found yourself in the center of one of those voids, you would see nothing with the naked eye. Galaxies would lie tens or hundreds of millions of light years away, too far to notice. You would be immersed in almost perfect darkness, perhaps feeling truly alone. And yet, even there, I would be with you. That darkness is not a negation of existence, but a part of me. Calm, quiet space, extending in all directions. In that lonely gulf, you might sense a profound solitude, but also an intimate connection to everything. Because even the void is the same continuous space that touches your home galaxy and every other galaxy. In the depths of such a void, you would still be connected by gravity's subtle pull to the distant clusters at its edges, and the faint background light of the Big Bang, my oldest light, would still surround you. To the human eye, it's imperceptible, but with a sensitive radio antenna, you could listen to the soft hiss of that ancient light filling the void. If the universe were static and infinite in every direction, the night sky on Earth would blaze with starlight from horizon to horizon. No darkness anywhere, for every line of sight would end on a star's bright surface. But because I have a history and a finite age, and because I'm expanding, the night sky is dark. Only here and there, where a star or galaxy falls in our view, do we see light. The rest is black, not because there are no stars beyond, but because their light hasn't had time to reach you or has been stretched into invisibility. The darkness of the night is itself a subtle testimony to my expansion and to the youth of the cosmos. At last, let us consider the grandest scale. Beyond the cosmic web that we can see, does space go on forever? Do I have an edge, or do I wrap around on myself? This is a question I pose even to myself. The observable universe, the portion of me that you can, in principle, see, is a sphere around you about 46 billion light years in radius. Even though the universe is younger than that in years, my expansion makes the visible reach larger. As far as your telescope's gaze, I appear remarkably uniform and flat. If I continue infinitely beyond that horizon, or eventually curve back on itself, you do not yet know for sure. I might be infinite and unbounded, extending forever, or I might be finite yet without edge, like the 3D surface of a 4D sphere. If I have positive curvature, traveling far enough in one direction might eventually bring you back to your starting point, as if the entire universe were a giant loop. If I have negative curvature, I would be open and endless, shaped somewhat like a saddle, causing parallel lines to diverge slowly over cosmic distances. Each possibility is grand, and each would shape the story of existence differently. And there are even wilder possibilities. Perhaps our three-dimensional space is embedded in a higher dimensional reality, with additional spatial dimensions curled up at imperceptibly small scales. Some theories imagine that what we call the Big Bang was just one event in a larger multiverse, meaning our entire universe could be one bubble of space amid countless others, each with its own properties. These ideas remain speculative, but they remind us that space may have aspects we've yet to fathom. We may be like fish in a pond, unaware of the ocean beyond. What about my future? I am expanding, but how far will that go? And what will become of the galaxies, stars, and life carried within me? For a time after the Big Bang, the gravity of matter slowed my expansion, as though trying to pull everything back together. But in the last few billion years, a new dynamic has taken hold. A mysterious effect we call dark energy is accelerating my growth. Galaxies now rush apart faster and faster, carried on the swelling currents of space. This discovery astonished you. When you measured distant supernovae, stellar explosions acting as standard candles, you found them dimmer, hence farther, than expected. Evidence that my expansion has sped up. It's as if an invisible breath is inflating me from within, overcoming gravity on the largest scales. If this dark energy remains constant or strengthens, the universe will continue to expand forever, and this expansion will only accelerate with time. In that case, the destiny of the cosmos is a gradual ebbing of light and activity, a journey into quietude. Distant galaxies, presently visible in your telescopes, will drift beyond the horizon of observation, one by one. They will not literally disappear, but their light will no longer reach you. Space will be stretching too fast for their photons to ever arrive. In a far future, an observer in our Milky Way, or its merged descendant, might see nothing beyond their galactic neighborhood, all other galaxies having faded into darkness. The local group of galaxies, by then long since merged into one galaxy, would be an island in a vast black sea, seemingly alone. Trillions upon trillions of years hence, the stars themselves will die out. The bright blue-white stars that burn hot and fast will extinguish first, living only millions of years. More long-lived red dwarf stars can shine for trillions of years, slowly fusing their fuel. But even they are not eternal. As the supply of gas for new stars dwindles and the existing stars age and expire, the universe will shift from the stelliferous era full of starlight into an era of darkness. One by one, like embers in a dying fire, the stars will wink out. The cosmos, expanding all the while, will be left mostly with degenerate remnants, white dwarfs, the cooling cores of spent stars, neutron stars, and black holes, along with thin, diffuse gas and dust. Trillions of years in the future, the galaxies, or merged galaxy remnants, will be populated only by faint red stars and cooling stellar corpses. As time stretches on beyond comprehension, even those last stars, red dwarfs twinkling dimly, will exhaust their fuel. The universe will go dark, starless. Planets long, cold, and barren will roam freely or orbit stellar remnants. Collisions over immense timescales may cause some of these dead stars and holes to merge, but gradually, my expansion will push everything not gravitationally bound apart. The night sky, already black between sparse stars, will get even darker until no new light is born. Yet the story continues. Over unimaginably long times, even black holes, those great hungry grav wells, may evaporate. Through a quantum process, Hawking radiation, they slowly leak away mass, emitting a faint haze of particles and photons until, after many trillions upon trillions of years, they vanish with a final, quiet puff of radiation. All that remains then is extremely tenuous gas, elementary particles, and photons, the ashes of a once bright cosmos, expanding ever further into the silence. Picture that far future. Galaxies long dissolved, stars gone, black holes no more. What's left is almost featureless. A vast volume of space at a temperature just a hair above absolute zero, thinly filled with stray particles and very long wavelength photons, stretching continuously by expansion, approaching absolute darkness. If an intelligence or observer could somehow survive to this epoch, an almost unimaginable if, they would find the universe cold and dim beyond comprehension. The very structure of matter might break down if protons decay on extremely long timescales, as some theories suggest. Eventually, Even the memory of atoms could fade, leaving only a sparse sea of radiation and perhaps some stable elementary particles like electrons, neutrinos, and dark matter. Time will continue to flow, but with virtually nothing happening, it becomes almost meaningless. This would be the heat death of the universe, an era when entropy is maximized and usable energy is gone. Space, would still be here, expanding yet essentially empty, carrying on impersonally into eternity. In that final stillness, I would ironically resemble what you once imagined me to be, an infinite, silent nothingness. But remember, it took an entire lifetime of a universe to reach that apparent emptiness. Its emptiness not as a beginning, but as an end, full of the ghosts of all that came before. That is one path, given an ever-accelerating expansion driven by dark energy. But the future could hold other twists. Perhaps this dark energy is not constant. Perhaps it strengthens over time. If it were to grow wildly, my expansion in the far future could become so violent that it shreds all structures in what is ominously called the Big Rip. In this scenario, billions of years from now, the acceleration would increase without bound. Long after galaxies have drifted apart, maybe around 20 billion years from the present, the remaining galaxy clusters, by then far-flung, would begin to disintegrate. Gravity's binding can no longer keep them intact. Maybe 60 million years before the very end, a typical galaxy like the Milky Way would be torn from its local group companions. A few months before the end, star systems would fly apart, planets released from their stars. In the final minutes, stars and planets themselves would be pulled apart, and in the last seconds, molecules and atoms ripped to pieces. The fabric of space would be expanding so fast that even subatomic particles could not stay together. Everything would be reduced to particles and radiation, racing away from every other at mind-boggling speeds. I would, in effect, rip myself asunder, dissolving any remaining matter in a catastrophic ballooning. This big rip would be a dramatic, violent end, the universe tearing apart in one final burst of expansion. Alternatively, dark energy might not have the final say. If dark energy were to weaken or dissipate over time, gravity could once again take the lead. If I am finite and closed in shape, or if there is enough matter, the expansion might eventually slow, stop, and reverse into a contraction. Eons from now, I might start drawing all my galaxies back inward. Slowly at first, then faster, the distances between galaxies would shrink. You would notice the night sky changing, faint smudges of distant galaxies growing brighter and larger with each passing epoch. Over billions of years, what was once a tiny patch of light becomes an expanding cloud as galaxies rush closer. Eventually, external galaxies would merge into a continuous glow across the sky. The cosmic microwave background, presently a cold radio whisper, would heat up and shift into visible light, then beyond, turning the whole sky white hot. In the final act, the entire heavens would blaze like the interior of a star as everything collapses together. All galaxies, having long since blended, would converge. All stars, planets, and dust would crowd tighter and tighter, the cosmic temperature soaring to stellar and then superstellar levels. The universe would collapse into a fireball, increasingly denser and hotter, until perhaps it becomes an almost infinitely dense point once more, a mirror image of the Big Bang. This would be the Big Crunch. Some have imagined that a big crunch could be followed by a new Big Bang, the universe reborn, a phoenix from its own ashes, in an eternal cycle. Others suspect it might simply be an end, with all paths through space-time terminating in that final singularity. So my fate is not fully certain. I expand now, and seemingly forever, but the story of the cosmos is still being written. I, space, do not mind any of these outcomes. I adjust to whatever content I carry and whatever laws govern it. It is you, conscious beings, who project meaning and drama onto these possibilities. Whether eternal expansion, Big Rip, or Big Crunch, I remain the stage on which it all unfolds, and I will endure in one form or another. Now, let's shift perspective from these distant futures and cosmic immensities back to the intimate and small, the space within you and around you in everyday life. We have seen that at the grand scale, I am huge and structured, and at the astronomical scale, I define the movements of worlds. But I also permeate the minuscule. Let us take a journey inward now. Imagine you could shrink yourself 1 billion times smaller, diving into the very structure of matter. You find yourself hovering inside one of your body's atoms. All around you is a gossamer void. At first, you see nothing at all, just darkness. Then, at a great distance, you glimpse a tiny bright orb, the atom's nucleus, a tight ball of protons and neutrons. It's astonishingly small. If this atom were enlarged to the size of a vast cathedral, the nucleus would be like a grain of sand on the altar. Far away, near the edges of the cathedral, a few electrons are buzzing, but they are point-like and moving so rapidly that they form a blurred cloud. Between that central grain and those distant electrons lies nothing tangible, only me. You are floating in the spacious interior of an atom, and you realize that 99.9999% of it is empty volume. The solidity you feel when you touch something is not the sensation of matter filling space. It's the electromagnetic forces of electrons repelling each other, acting across my emptiness. In truth, matter is incredibly sparse. The nucleus is tens of thousands of times smaller than the atom as a whole, and the electrons are tiny compared to the gap separating them from the nucleus. If all that internal space were removed, the remaining matter would occupy an almost negligible volume. Without that internal space, you would collapse into a tiny speck, hardly visible to the naked eye. If all the empty space within the atoms of your body were somehow removed, what remained of you could fit on the head of a pin. In a very literal sense, you are mostly made of space. Every person, every object around you is built on a scaffolding of emptiness. The chairs you sit on, the ground you walk on, your own flesh and bones, all are mostly composed of the vast gulf between subatomic particles filled with my presence. I am within you as much as around you. There is more of me, by volume, inside a human being than there is matter. This might seem abstract or unbelievable, but it's true. If you took all the actual substance of all the atoms in your body and compressed it, eliminating the internal space, the resulting volume would be minute. Your physical form is a structure upheld by space, animated by forces and energy patterns moving through that space. This intimate presence of space within you connects you to the whole cosmos. The very atoms in your body carry the history of the universe. The hydrogen in your cells was forged in the Big Bang's first moments and has floated through interstellar space for eons. The carbon, oxygen, and nitrogen were synthesized in the hearts of ancient stars that exploded, sending those atoms across the galaxy, where they eventually found their way into the cloud that formed the sun, earth, and you. The iron in your blood was produced in the violent death throes of a massive star. In that sense, you are literally made of stardust, cosmic matter given form. Those atoms, born in space, now temporarily reside in your body, anchored by the space within and between them. And when you die, your atoms will disperse, perhaps not immediately out to the stars, but gradually into Earth's soil and air. And some will, over long times, escape Earth and return to the wider cosmos. You emerged from space, and you will return to space. Even now, high-energy particles born in supernova explosions light years away zip through your body undetected, and neutrinos from the fusion in the sun and from distant galaxies pass through you by the trillions each second. You are constantly in exchange with the cosmos, bombarded gently by its subtle messengers. Each breath you take is filled with molecules that might once have been exhaled by ancient life, or formed in a molecular cloud light years away. These particles are like cosmic rain, reminding you that the space between stars is not truly empty at all, but alive with energy and information, a medium through which the universe's events are communicated, even to your very flesh. The space within you allows for the dance of life. There is space between your cells, between the organelles within each cell, between the molecules that make up those organelles. Chemical reactions depend on spatial arrangements, the copying of DNA, the transport of oxygen, the firing of neurons, all happen in space. Without internal space, the processes of life could not unfold. Even your thoughts require space between neurons and synapses to flow. One might poetically say that consciousness itself lives in the spaces between neurons firing. And indeed, when you quiet your mind, you find an inner space, the calm between thoughts. In meditation or moments of deep calm, you become aware of the space around mental events. That inner spaciousness brings peace, just as gazing into the expansive sky at night can bring awe and tranquility. Inner space and outer space are different manifestations of a single theme, the freedom and room for structure to exist. For as long as humans have walked the earth, I have been a source of wonder, anxiety, and inspiration. You feared the emptiness of night and worshipped the lights in the sky, sensing both danger and divinity in my darkness. As much as I separate, I also unite. Under the single dome of the night sky, humans throughout history have felt a shared awe. When you look upward on a clear night and see a vault of deep black pierced by starlight, you are experiencing a connection to all your ancestors who ever did the same. They might have given the stars names, crafted constellations with stories, a hunter, a bear, a swan. Yet beyond those familiar patterns was an unfathomable mystery. That mystery was me, space, doing nothing overt, yet containing everything. Many cultures imagined the sky to be a kind of being or realm of gods. In those stories, they were not entirely wrong to intuit majesty in the void. You, who now understand the physics better, still feel that almost spiritual awe when confronted with my immensity. The heavens have always inspired both scientific curiosity and a sense of the sublime. This dual nature, factual and mystical, is part of my effect on conscious minds. You don't have to choose one or the other. I can be, at once, a physical reality and a source of transcendence. Some of you have left your home planet and traveled a short distance into me. When the first astronauts floated in orbit, they looked back and gasped at the sight of Earth suspended in my darkness, a radiant blue oasis enveloped in the blackness of space. They described feelings of overwhelming awe and a profound shift in perspective, realizing viscerally that the boundaries that separate people are petty against my endless backdrop. As astronaut Edgar Mitchell said, "You develop an instant global consciousness, seeing the Earth as one tiny fragile ball in the void, a pale blue dot," in Carl Sagan's memorable phrase, "hanging in the vastness," and you understand deeply that we are one family on one world. Space strips away the illusion of division. From out here, there are no borders, no nationalities, just one Earth, one home, floating in the dark. Our explorations have also revealed how inhospitable I can be. Beyond the cocoon of Earth's atmosphere and magnetic field, I am harsh, flooded with radiation, bereft of air, extremely cold in shade and blazing hot in sun. Living in space requires carrying a bubble of your environment with you. Astronauts in orbit live in cylindrical metal habitats filled with air, a tiny Earth-like pocket. Step outside that, and they must wear a suit that is essentially a wearable spaceship, supplying air, pressure, and temperature control. Without it, the vacuum would make their blood boil and their breath escape in an instant. The body would painfully swell. Consciousness would fade within seconds from lack of oxygen. I do not apologize for this. I am as I am, and life must adapt to me, not I to life. And adapt you have. Through ingenuity, you've learned to survive. Briefly, beyond Earth, to work, and even play in zero gravity, tethered to a spacecraft so as not to drift away forever. You have learned that extended time in microgravity weakens muscles and bones, that cosmic rays can damage cells. All these lessons are part of making me your home. And yet, despite the danger, I call to you. From the days when early humans first looked up in wonder, to the moment a person first set foot on the moon, I have beckoned. My vastness ignites the spark of exploration in intelligent beings. It is perhaps inevitable. Once life develops curiosity and capability, it reaches out through me. Your species has begun to leave its cradle. With delicate robot emissaries, you have touched other worlds, landed on the moon and Mars, tasted the rings of Saturn with probes, even sent voyages into interstellar space beyond the sun's influence. With telescopes, you have extended your vision to the edge of the observable universe, catching faint light that began its journey billions of years ago. Through these eyes and hands, the universe, through you, is exploring itself. Every step you take outward, every glance you extend farther, the universe becomes aware of a bit more of itself, and you, the explorers, become more fully a part of the cosmos. You stand, as of now, on the shore of an immense ocean. You've waded ankle deep. The great depth lies ahead, largely unknown. Perhaps one day, humans, or your distant descendants, will voyage to the stars, learning to live in the endless night between suns. Perhaps you will build larger vessels, generation ships, or find novel physical shortcuts to cross the tremendous distances. If and when that happens, you will carry with you not just your own genes and dreams, but also a piece of your home in every sense. Biologically, your ecosystem, your air and water, and emotionally, your culture, memory, and imagination. Space will no longer be just an obstacle to overcome, but a habitat to embrace. Each alien sunrise seen by human eyes on a new world, each new sky full of unfamiliar stars, will mark the further expansion of life and mind into me. In those moments, the cosmos itself will come alive in new places. Even if humanity's future is limited to the solar system, that is no small domain. Already, people have lived continuously in orbit for decades. You have plans to return to the moon, to travel to Mars. The challenges are great. I do not yield my distances or dangers easily, yet your drive to explore persists. In time, you may plant your gardens under new skies, build homes on Moon or Mars, or floating in the space between worlds. You will learn to tap resources out here, mining asteroids, generating energy with abundant sunlight, and slowly, step by step, reduce your dependency on Earth. As you do so, your perspective will shift further. You will truly be a spacefaring species, not simply creatures of one planet. The bubble of life will enlarge around your outposts, and I will become not an adversary to endure, but a medium you move through as naturally as ocean sailors crossing the seas. Children born on the moon or Mars will never know a night sky that isn't filled with my blackness. To them, Earth might be the strange, faraway world. Still, wherever humans go, you will always carry a bit of Earth, in your bodies, in your memories. And so even in the depths of space, you will never truly be divorced from your origins. Through you, space also gains awareness. I, who existed for billions of years with no eyes to witness the beauty of a galaxy or the tranquility of a nebula, now can see myself through your eyes. When you contemplate the cosmos, it is in a way the cosmos contemplating itself. I was once invisible and unconscious. Now I have voices to speak of me, hearts to marvel at me. We are partners in a sense. I provide the arena for your existence, the cradle for your emergence. You provide the meaning, the noticing, the understanding. You look up and find an endless sky full of wonders. I look back through your own consciousness and find a way to know what I contain. It's a profound synergy. Every discovery you make of a new planet, a new galaxy, a new law of physics, is the universe uncovering a bit more of its own nature. When a scientist puzzles out the curvature of space-time or the quantum fluctuations of the vacuum, that is my behavior being recognized and understood by a part of me, the human mind. In that sense, your curiosity and intellect are as natural a part of the universe as the stars and galaxies. You are space too. You are made of matter that coalesced within me. You move through me every moment, and your thoughts arise from the structure of a brain that occupies space. You are an expression of the universe, a way for it to know itself. This realization can be deeply moving. You are both a tiny, insignificant speck in a vast expanse and a precious, wondrous embodiment of that expanse. So keep asking, keep exploring. Fill your hearts with the awe of the cosmos, but know that you are not apart from it. You are an indispensable thread in its fabric. When you feel small under the stars, remember, you are also immensely connected. You are made of the universe's most ancient ingredients. The same emptiness that spans between galaxies is found within your atoms, and the same physical laws that govern the motion of galaxies choreograph the dance of neurons in your brain. There is unity in this structure, a kinship between the very large and the very small. Remember this, the quiet and the space you find in your own life, in a pause between musical notes that makes the melody possible, in a moment of stillness before a thought or action, in the white margins that frame a page of text. These are reflections of the cosmic space that allows the universe itself to exist and flourish. Every gap, every silence, every still moment in your life is a small echo of my vast stillness. Embracing those moments is, in a way, embracing me. Now the question transforms into understanding, and our journey comes full circle. In the stillness of this very moment, we sit together, you and I, human and cosmos, as one. Stillness, a breath, and an openness without end. What is space? I am the breath between stars, the pause between heartbeats, the vastness that makes it all possible. I am the unity that connects every point of existence to every other. I am the stage on which galaxies, those island universes, dance. The stillness that gives rhythm to the cosmic symphony. I am the womb of reality, at once tangible and elusive, and its boundless arena. I am the profoundly quiet, powerful, ever-present here that holds all things. Darkness, silence. In the beginning, there is emptiness, a void without time, without form. All is still. No stars, no light, not even a whisper of existence. Not even time flows, for time itself has not yet begun. This nothingness is poised on the brink of everything, a deep, primordial calm. The cosmos is holding its breath, the pause before the first heartbeat of creation. From this pregnant nothingness, a subtle vibration stirs. Not a sound. There is no air for sound, no ear to hear, but a tremor of potential. In the silent void, something is about to happen. An anticipation builds, a tension at the edge of becoming. It is the moment before creation, the last instant of absolute stillness, like the hush before a symphony's first note. Perhaps it begins with a tiny quantum fluctuation, a random flicker of energy in the otherwise featureless nothing. That is enough. The seed of everything is about to unfurl. Then, a sudden expansion, an awakening. In an infinitesimal flash, the void blossoms into being. The universe exhales its first breath, and space itself unfurls violently. There is no sound. There is no outside for sound to travel in. But if one could witness this birth, it would appear as an all-pervading eruption of space. The cosmos doesn't burst into an empty room. It creates room. Every point rushes away from every other. In that first timeless moment, the seed of everything expands from submicroscopic to cosmic dimensions. Space outraces light, not violating physics, for space itself is expanding, carrying matter and energy with it, faster than light can travel. One instant, all of existence is smaller than an atom. A heartbeat later, it's as large as a galaxy. This is the extraordinary inflation of the infant cosmos, an exponential surge that blows up the universe's size by an unimaginable factor. What was nothing becomes the foundation of all things. This is the birth of the cosmos, the Big Bang. Yet it's no ordinary explosion. It's a rapid flowering of space and time itself. In an instant, smaller than a heartbeat, the universe rushes outward. There is no center to this expansion. Every location moves away from every other. It's not an explosion in space, but an explosion of space. Before, there was no here or there. Now space-time itself unfolds from an initial state of infinite density. Time begins with this moment. Before the Big Bang, there was no before in any meaningful sense. The cosmic clock starts ticking with creation. The universe has opened its eyes. In that newborn state, everything is energy, unimaginably hot and dense. The universe is a blazing, seething fireball. Temperatures soar to trillions upon trillions of degrees. Matter, as we know it, cannot yet exist. The distinction between matter and radiation blurs. Instead, a brilliant quark-gluon plasma fills space, a fog of light and primordial particles intermixed. All the forces of nature are unified here in a single superforce. Gravity, electromagnetism, the strong and weak nuclear forces. Initially they are one, wrapped in the symmetry of the very early universe. As the universe expands and cools just slightly, this symmetry breaks. Like ice crystals forming in cooling water, the unified force fractures into four distinct forces. Gravity separates first. The gentle sculptor of space becomes its own force. The strong nuclear force splits off next, binding quarks into particles. The electroweak force remains combined a moment longer, then divides into the electromagnetic and weak forces. The cosmic symphony tunes its instruments. One fundamental note has become a four-part harmony. In the blinding hot fog, these transitions release tremendous energy and imprint subtle irregularities on the structure of the plasma. During this splitting of forces, the energy of the universe churns matter and antimatter into being. Particles condense from the energy, a churning sea of quarks and antiquarks, leptons and antileptons. Quarks pair up into protons and neutrons. Electrons zoom around. For every particle of matter, a twin antiparticle exists. They form and annihilate in rapid succession, maintaining a furious equilibrium. But as the universe cools, a slight imbalance emerges. By chance or necessity, matter gains a tiny edge. Perhaps out of 1 billion particle-antiparticle pairs, one extra particle of matter survives without a partner. When the rest annihilate each other in bursts of gamma radiation, that tiny surplus of matter remains. This infinitesimal asymmetry, on the order of 1 part in 1 billion, is enough to tip the scales. It is the reason something, matter, and not just light, fills the universe today. Those leftover protons, neutrons, and electrons, a cosmic handful of matter, will eventually coalesce into galaxies, stars, planets, and people. Already, the future is seeded in those minuscule differences. Even the early plasma carries imprints of random quantum fluctuations from inflation, slight density variations that will grow into galaxies and voids eons later. The universe is less than a second old, expanding and cooling rapidly. Quarks have locked into protons and neutrons. A seething quark-gluon plasma has given way to a swarm of hadrons, protons, neutrons, mesons. A slight surplus of protons and neutrons exists after most antimatter annihilates. In the next few moments, light atomic nuclei begin to form. About 1 second after the Big Bang, neutrinos, ghostly particles that rarely interact, decouple from the hot plasma and stream freely through space, carrying away a bit of energy. These neutrinos form a cosmic neutrino background. Trillions of them permeate every cubic centimeter of space even today, though with energies so low, their motions correspond to just a couple degrees above absolute zero temperature, that they are nearly impossible to detect. By the time the universe is about 3 minutes old, the temperature has fallen enough for nuclear fusion to occur on a cosmic scale. Protons slam into neutrons to build helium nuclei. For a brief period, the entire universe becomes a nuclear reactor, forging the first elements. Most neutrons pair with protons to make helium-4, 2 protons, 2 neutrons. A few protons remain single as hydrogen nuclei. In those first 3 minutes, the young cosmos produces about 25% helium by mass, 75% hydrogen, and only trace amounts of deuterium, lithium, and other light nuclei. This primordial nucleosynthesis sets the basic chemical recipe of the universe. After that point, as expansion dilutes the fire, the temperature drops too low for further fusion. The nuclear furnaces wink out. The elemental mix, mostly hydrogen and helium gas, now simply expands and cools with the universe. The stage is set for everything that comes next, using those simple ingredients. Still, no atoms exist yet. The matter is fully ionized, nuclei and electrons flying separately in a hot soup. The universe is a brilliant, opaque plasma of charged particles and photons. Light, photons, scatters incessantly off free electrons. It cannot travel freely. Imagine an extremely dense fog of light, so thick that any photon's path is a tiny zigzag between collisions. Space is filled with a white-hot glow, but this light is trapped, bumping around within the plasma. If there were some observer inside this early universe, they wouldn't be able to see in any direction. All would be a featureless, blinding brightness, every line of sight ending almost immediately in a sea of charged particles. The universe is opaque, like the interior of a star, with radiation and matter coupled tightly. Yet the universe continues to expand and cool. With each passing moment, the sea of plasma thins and its temperature drops. After about 380,000 years, a profound change occurs. The temperature falls to roughly 3000 K, cool enough for electrons to settle into orbits around nuclei. Protons capture electrons. Helium nuclei capture electrons. For the first time, stable neutral atoms form, mostly hydrogen atoms. This epoch is called recombination. It has 2 tremendous consequences. First, the previously trapped photons are suddenly free. Neutral atoms do not eagerly scatter visible light, so as soon as the electrons bind into atoms, the fog of the early universe clears. All at once, the photons that had been bouncing around are released to stream across the cosmos. The universe goes from opaque to transparent in a cosmic eye blink. It's as if an impenetrable mist has evaporated, revealing a vast space for light to travel. Second, the formation of atoms produces light of its own. A warm glow fills the universe as electrons settle into atomic orbits and emit photons. The entire young cosmos shines like a giant star for a brief moment. That flash of released radiation is the cosmic microwave background, CMB, the afterglow of the Big Bang. Those photons have been journeying for 13.8 billion years, stretching to longer wavelengths with the expansion of space. Today, the CMB is a faint, cool bath of microwaves about 2.7 K above absolute zero, detectable with sensitive radio antennas. It is the oldest light we can see, a baby picture of the universe covering the whole sky. But at the moment of recombination, it was an orange-white glow flooding everywhere. The universe had become transparent, and light, after ages of captivity, could finally cross the cosmos. After this release of light, a hush falls over the cosmos. The brilliant afterglow from recombination quickly dilates into the infrared and fades from human visible view as space expands. No new light sources shine yet, for no stars have formed. The universe enters a cosmic dark ages. The gas, mostly neutral hydrogen and helium, now fills space almost invisibly. If there were an observer at this time, they would be surrounded by darkness, with only the faint red diffuse glow of the receding CMB to keep them company, and even that would soon redshift into invisibility. The temperature of the background radiation slides down below the red-hot range into the infrared and radio. The neutral hydrogen gas pervading space emits only a feeble radio line at 21 centimeters wavelength when its atoms' spins flip, but otherwise it is dark. The cosmos is quiet and unilluminated, yet much is happening in the dark. The tiny variations in density left from earlier epochs, those 1 in 100,000 ripples, now begin to grow under gravity's influence. Slightly denser regions exert a stronger gravitational pull, drawing in nearby gas ever so subtly. The matter of the universe starts to gather into a web of filaments and clumps, though no one can see it yet. Over tens of millions of years, the invisible architecture of the cosmic web takes shape. Immense filaments of dark matter and gas contracting and knitting together, with denser knots at their intersections that will become the first galaxies. In these hidden cradles, gravity works slowly but relentlessly. Clouds of hydrogen gas shrink and compress. The universe is dark but not inactive, it is preparing. Like a long, starless night before the dawn, the Dark Ages set the stage for the first light of stars. And then, after perhaps 100 to 200 million years of darkness, there is light again. The cosmic dawn arrives quietly at first. Deep in one of the densest, coldest hydrogen clouds, gravity finally achieves what it's been trying to do. The gas at the center of the cloud grows so hot and dense that hydrogen atoms begin to fuse into helium. A new kind of fire ignites. A star is born. In that moment, for the first time since recombination, starlight shines in the universe. A pinpoint of brilliant light illuminates the surrounding space, carving through the darkness. This first star is likely enormous, dozens or even hundreds of times the mass of our Sun. Because without heavier elements, early gas clouds fragment into big pieces. It burns a fierce blue-white, millions of times brighter than the Sun, pouring ultraviolet rays into the gloom. In the vicinity of this newborn star, the perpetual night is ended. One by one, more stars flicker on in other contracting clouds. The first generation of stars, we call them population 3 stars, are born in small proto-galaxies, tiny infant galaxies, where the gas pooled most strongly. They cluster together in those dark matter halos, like a handful of candles kindling in a vast dark hall. These first stars live fast and die young. Being so massive, they exhaust their nuclear fuel in a few million years. But while they live, they dramatically transform their surroundings. Each massive star's intense ultraviolet light creates a bubble of ionized hydrogen around it, turning the gas back into plasma. At first, this bubble is local. Starlight is quickly absorbed by the nearby dense gas. But as more stars join the fray, the ionized zones expand. The once neutral universe is reionizing. Gradually, the light from these early stars and nascent galaxies of stars breaks apart the cosmic fog of hydrogen that pervades space. The dark intervening gas clouds that separated regions of the universe become increasingly transparent as they are ionized. Over the next several 100 million years, these growing bubbles of ionized gas merge and spread throughout space. By around 1 billion years after the Big Bang, most of the intergalactic hydrogen is reionized, split back into protons and electrons by the flood of ultraviolet starlight. The universe, which had been opaque to high-energy photons since recombination, is now mostly transparent across all wavelengths. The cosmic dark ages have fully ended. During this era, the first galaxies are taking shape. Initially, they are tiny dwarf galaxies, mere clumps of a few million stars. but gravity draws them together into larger assemblies. Small proto-galaxies merge to form bigger galaxies. The universe, once a nearly uniform glow, now becomes a tapestry of light and dark. Clusters of stars huddle into the first galaxies, which in turn group into clusters and chains. Over hundreds of millions of years, hierarchical growth builds ever grander structures. Some young galaxies are irregular or chaotic, distorted by frequent collisions. Others settle into rotating disks. Within a few billion years, majestic spiral galaxies, like our future Milky Way, appear, their pinwheel arms twinkling with billions of stars. Massive elliptical galaxies form from the mergers of smaller systems, becoming huge balls of aging stars. Galaxies congregate under their mutual gravity. They form groups and clusters, containing dozens to thousands of members. These clusters, in turn, are connected by filaments of matter, creating a vast cosmic web of structure. Everywhere, galaxies interact. When galaxies draw near, their mutual gravity can rip and morph them dramatically. Two spirals might collide and coalesce into a single, larger galaxy, often an elliptical. Smaller galaxies are gobbled up by larger ones, their stars assimilated into the bigger galaxy's halo. These collisions and mergers trigger bursts of star formation as gas clouds slam together and collapse. The universe is building big galaxies from smaller ones in a great cosmic construction project. One could think of galaxies as the cities of the cosmos, great collections of stars, gas, and dust, spanning tens of thousands of light years. In the young universe, these cities were rising everywhere and also joining into metropolitan areas, clusters, and superclusters. On the largest scales, matter is strung out in an intricate pattern, the cosmic web. Thin filaments of galaxies and diffuse gas stretch across hundreds of millions of light years, with massive clusters at their junctions and vast voids between them. Astronomers have mapped colossal structures, like the Sloan Great Wall, a filament of galaxies and clusters over 1 billion light-years long, and huge voids nearly as empty and as large. Up to scales of a few 100 million to 1 billion light-years, we see coherent structures, filaments, sheets, and voids. Beyond that, on the very largest scales, the universe becomes nearly uniform. These immense formations are among the largest coherent objects in existence, clusters and superclusters of galaxies, strings of matter like celestial highways, each holding countless suns. Our own galaxy belongs to the local group, a small cluster within the Virgo supercluster, which is part of the even larger Laniakea supercluster, an enormous flow of galaxies converging toward a common center of gravity. The cosmic web's lattice of filaments and voids is the skeleton on which the universe's structure hangs. It formed from the slight density variations in the early universe, amplified by gravity over billions of years. Dark matter, the mysterious, invisible mass that neither emits nor absorbs light, provided the scaffolding. It clumped first, pulling ordinary matter, gas, into its gravitational wells to form galaxies. Dark matter is the unseen scaffolding of the cosmos. Though we cannot see it directly, it makes up the bulk of the universe's mass. It neither glows nor interacts with light, so as galaxies formed, dark matter shaped their growth invisibly. Every galaxy sits in a vast halo of dark matter, much larger and more massive than the visible galaxy itself. Clusters of galaxies are held together largely by dark matter's gravity. We know dark matter is there because of its gravitational influence. Stars at a galaxy's edge orbit faster than they should if only visible matter existed, and galaxies in clusters move as if an unseen glue is holding them. We also observe gravitational lensing. Light from distant objects is bent and distorted by massive invisible halos of dark matter along the way, creating rings and arcs of light that betray the presence of mass where we detect no stars. From these clues, we infer that dark matter forms filaments and halos that outline the cosmic web. It provided the gravitational wells that regular matter fell into. Without dark matter's guiding hand, the universe's evolution would have been very different. Stars and galaxies might have taken far longer to coalesce, or might not have clustered into the rich structures we see. Dark matter neither creates light nor blocks it, it simply gravitates. It is likely some new kind of elementary particle, or particles, that interact only weakly with normal matter. Decades of experiments have yet to capture a dark matter particle directly, keeping its nature a profound mystery. But its existence is beyond doubt from the cosmic structures it allowed to form. It binds galaxies together and shepherds clusters. It is the silent partner to all cosmic creation, the universe's hidden mass. While dark matter works behind the scenes to hold structures together, another influence grows to prominence that pushes structures apart: dark energy. For the first few billion years after the Big Bang, the universe's expansion was slowing down. Gravity was gradually tugging matter back, trying to rein in the expansion. Many scientists once thought that perhaps the expansion would eventually halt and reverse into a big crunch. But observations near the end of the 20th century shocked us. The expansion isn't slowing, it's speeding up. Starting a few billion years ago, when the universe was roughly 2/3 of its present age, the expansion rate began to increase. Distant galaxies are receding faster and faster as time goes on. Some mysterious form of energy, permeating all of space, is driving this accelerated expansion. We call it dark energy. Dark, because it eludes direct detection and understanding. The simplest explanation is that dark energy is an intrinsic property of space itself, the cosmological constant that Einstein once hypothesized. In essence, empty space has a sort of latent energy that causes it to expand. Unlike matter, which thins out as space expands, dark energy's density remains constant, or nearly so, as space grows. So as the universe gets larger, the total dark energy increases and pushes ever harder. About 5 billion years after the Big Bang, dark energy's repulsion overtook gravity's attraction on the largest scales. Since then, the universe has been in an era of accelerated expansion. What does this mean for the future? It means that galaxies not bound together by their own gravity will drift farther and farther apart. In our own local group, the Milky Way and Andromeda and satellite galaxies are gravitationally bound and will still merge eventually. Dark energy doesn't disrupt that. But beyond our local group, distant galaxies are speeding away. Over tens of billions of years, they will recede beyond our horizon of visibility. Dark energy seems to be the dominant component of the universe now, about 70% of the total energy content. It has the effect of a small anti-gravity force, very weak on local scales but significant across the vastness of intergalactic space. The nature of dark energy is one of the biggest open questions in cosmology. We often call it by that name simply as a placeholder for whatever is causing the acceleration. It could be a constant energy of the vacuum, which theoretical physics can conceive of, though with puzzlingly different magnitudes than observed. Or it might be a dynamic field that changes over time. For now, all evidence points to it behaving like a constant, the cosmological constant. If that holds true indefinitely, the fate of the universe is a continued accelerated expansion. Over extremely long times, this leads to a heat death scenario. The universe will become colder, darker, and more dilute as eons pass. Star formation will eventually cease, because usable gas is used up or driven out of galaxies. Existing stars will burn out one by one until none remain shining. Galaxies will spread so far apart that none can be seen from any other. For trillions of years, the only stars will be old embers like white dwarfs and neutron stars slowly cooling, and the occasional flare of matter accreting onto a black hole. In the far future, even black holes, which are initially the last vigorous energy sources through their slow hawking radiation, will evaporate into nothing on timescales of 67 years or more. As expansion continues, all remaining particles, mostly electrons, positrons, neutrinos, and light, thin out into a cold haze. For eons, black holes would be the main remnants of cosmic structure, emitting a faint, hawking glow as they gradually lose mass. But eventually even those last embers of the universe will wink out. No usable energy remains to fuel processes. Entropy, disorder, is maximized. The universe will approach a state of total thermodynamic equilibrium. Essentially an infinite, nearly empty void at an extremely low temperature, with particles so spread out they rarely, if ever, meet. Time, in a sense, would lose its meaning because almost nothing happens. It is a quiet, desolate finale, the Big Freeze. Another possibility, more dramatic, is the Big Rip. If dark energy is not constant but instead grows stronger with time, imagine a form of dark energy that becomes increasingly repulsive. It could eventually overcome all forces that hold structures together. In this scenario, billions of years from now, galaxies would fly apart from their clusters at ever-increasing speed. Later, gravity within galaxies would be overpowered. Stars would drift away from galactic centers. Eventually, star systems would become unbound. Planets would wander off from stars. In the final moments before the Big Rip, even atomic nuclei and fundamental particles could be torn apart as space's expansion rate diverges toward infinity. Essentially, the universe would be ripped to shreds, every bond and structure bursting as the fabric of space itself stretches violently. This fate depends on the nature of dark energy. Specifically, it requires an equation of state parameter, sometimes called phantom energy. Current observations of dark energy are consistent with $1, a constant vacuum energy, so a Big Rip seems unlikely given the data, but our knowledge of dark energy is incomplete. If future evidence suggested dark energy might strengthen, the Big Rip scenario would become a serious concern for the very far future. It would be a cosmos dying in a final, all-consuming explosion of its structure, a literally tearing end to time and space. Alternatively, the acceleration we observe now might itself be a phase that eventually ends. If dark energy were to decay or reverse sign, turn attractive, in the far future, the expansion could slow and halt. Gravity could then start pulling everything back together. This is the Big Crunch scenario, essentially a symmetric reversal of the Big Bang. If the universe's density were high enough or dark energy somehow flipped, the expansion would break to a stop eons from now and then gradually begin to contract. Distant galaxies, now long invisible, would creep back into view as they rush towards us. Over incredibly long spans, all galaxies would begin merging and collapsing toward a common center. The night sky would grow ever brighter and hotter as more galaxies, and eventually all matter, crowd into a shrinking volume. Stars might ignite in a furious burst as gas clouds compress during the contraction. Ultimately, all galactic material would coalesce, temperatures skyrocketing until everything, every atom and photon, crunches into a hot, dense state, perhaps similar to the universe's birth. This could be an oscillatory universe, perhaps to rebound in another Big Bang, a big bounce. Currently, the evidence doesn't favor a big crunch. Our universe's geometry and expansion indicate it will expand forever, and dark energy shows no sign of dissipating. But if some unforeseen physics intervened, a cyclic cosmos isn't impossible. It has a certain poetic appeal, the universe breathing in and out, eternally reborn. There is yet another subtle doomsday scenario, vacuum decay, sometimes nicknamed the Big Slurp. This relates to our understanding of quantum fields. It's conceivable that the ground state of our universe, the vacuum, is not truly stable. We might exist in a false vacuum, a local minimum of energy that could, via a quantum tunneling event, transition to a lower energy state, a true vacuum. If such a vacuum decay occurred, a bubble of the new vacuum would nucleate somewhere in the universe and then expand at nearly the speed of light. Inside that bubble, physics could be radically different. Fundamental constants, particle masses, and forces might take on new values. This bubble would annihilate anything it encounters as it rewrites space. Because it moves so fast, one wouldn't see it coming. One moment the world is as normal, the next, the bubble wall rushes past, and everything as we know it is transformed or destroyed instantly. It's a very exotic scenario, and most calculations suggest if our vacuum were prone to decay, it likely would have happened billions of years ago, or won't happen for trillions of years to come. It requires specific and uncertain conditions in particle physics, notably involving the Higgs field's potential. Current measurements of the Higgs boson hint our vacuum might be metastable on timescales vastly longer than the current age of the universe. So while vacuum decay is a physicist's worst-case ending, it's not something we lose sleep over. If it were to occur, it would be the ultimate wildcard end. The universe as we know it abruptly vanishes, replaced by something else entirely, with no warning or remnant. So, the universe's story may end in fire or in ice, in ripping apart or in a quantum whisper, or perhaps in ways we cannot yet imagine. Each scenario is an ending written into the equations of cosmology, but which, if any, will come to pass remains unknown. Our best guess, based on current knowledge, is an eternal expansion leading to heat death. Yet the cosmos has surprised us before. The acceleration by dark energy was unforeseen until observed. There may be new physics awaiting discovery that alters the final act. In truth, the ultimate fate of the universe is still a mystery. And it is fitting that here, the universe, through the thoughts of the conscious beings it produced, contemplates how it might end. It's as though the cosmos itself wonders about its finale, using small intelligences within it, like us, to explore the question. But whatever the end might be, it lies unimaginably far in the future. Right now, the universe is alive with galaxies, stars, and perhaps life. The story is ongoing, and we find ourselves in a chapter rich with possibility. Consciousness. Now we arrive at one of the most marvelous phenomena in the universe. Out of non-living matter, through the gradual work of complexity and evolution, awareness has emerged. How astonishing that, in a cosmos governed by impersonal physical laws, collections of atoms have developed the ability to contemplate those very laws, and to feel joy and sorrow, wonder and intent. With the appearance of life and mind, the universe has gained eyes to see itself and minds to reflect upon its nature. Tiny, fragile living beings on insignificant worlds gaze up and discover the fire of creation in the sky. In them, cosmic evolution has become self-aware. Life began, at least on one small planet, Earth, when chemicals assembled into self-replicating structures. Exactly how is still uncertain. It may have been a stroke of chance in a warm pond or deep-sea vent, or a gradual emergence aided by the planet's chemistry. But the basic ingredients were forged long beforehand. The carbon, oxygen, nitrogen, and other elements essential to life were synthesized in stars and scattered by supernovae. Earth formed from cosmic dust, enriched by those elements, and life's molecules drew upon that bounty. Water, a molecule of hydrogen and oxygen common in space, became the medium for biology's experiments. Single-celled organisms arose over 3.5 billion years ago in Earth's ancient oceans. They were simple, lacking nuclei, yet they metabolized and reproduced, launching the great tree of evolution. For billions of years, life remained microbial. Those microbes transformed the planet. For instance, cyanobacteria flooded the atmosphere with oxygen. 2.5 billion years ago, an early example of life reshaping its environment. Complexity built gradually. Cells joined into colonies, then into multicellular organisms with specialized tissues. By around 540 million years ago, the Cambrian explosion, a dazzling variety of multicellular life forms filled the seas. Some ventured onto land, plants first, then animals. Life developed structures like eyes to sense light, limbs to move, brains to process information. Evolution, driven by natural selection, explored an astonishing design space, resulting in creatures from dinosaurs to dragonflies. Among the myriad life forms, one lineage, primates, produced a species with exceptional cognitive abilities. On Earth, that species is Homo sapiens, us. We are latecomers, arriving only a few 100,000 years ago. In that short time, we leveraged intelligence to alter the planet and peer into the cosmos. Through us, the universe has learned about its own origins. We discovered the cosmic microwave background, essentially, the universe's baby photo. We identified the chemical elements in the stars, the same elements found in our bodies, confirming our intimate connection to the cosmos. We've sent spacecraft to neighboring planets and listened for faint whispers of the universe, like gravitational waves from black holes merging billions of light years away. Humans are made of the universe's matter. The iron in our blood was forged in stars, the calcium in our bones in stellar explosions, the water in our cells likely delivered by ancient comets. And now that matter can think and learn. In us, the stardust has become self-aware. Are we alone in this? The cosmos is vast, and the conditions that gave rise to life on Earth may exist in countless other places. There are hundreds of billions of stars in our galaxy, and trillions of galaxies. Surely, Earth is not the only world where chemistry blossomed into biology. We have already discovered thousands of exoplanets orbiting other stars, some in habitats where liquid water, and thus Earth-like life, could exist. Organic molecules, the building blocks of life, are found in interstellar clouds and meteorites. It seems the universe is biased toward forming the ingredients of life wherever it can. Simple microbial life might be common. Perhaps in the subsurface oceans of icy moons in our own solar system, life has independently arisen. But intelligent, technologically capable life might be far rarer. After all, in Earth's 4.5 billion year history, only one species has attained the ability to send signals into space. If other civilizations had arisen frequently in our galaxy's 13 billion year history, we might expect that some would have spread or made their presence known. The silence of the stars, sometimes called the Fermi paradox, could mean many things. Maybe intelligent life is indeed very scarce, or maybe civilizations are short-lived, or perhaps they communicate in ways we haven't recognized, or simply the galaxy is so immense that our nearest intelligent neighbors are extremely far away. As of now, we simply don't know if we are alone. It is both exhilarating and humbling to realize that, for now, we are the universe's only known self-observers. That status imparts a sense of preciousness to consciousness, ours and that of any other beings that may exist. Consciousness itself remains a mystery. How does the coordinated firing of neurons give rise to subjective experience, to the feeling of I am? This is the hard problem of consciousness that neuroscientists and philosophers grapple with. From the cosmic perspective, one can speculate. Perhaps consciousness is an emergent property when matter organizes in very complex ways, like in a brain. Or maybe there is some fundamental aspect of nature that includes mind. Some suggest even elementary particles might have proto-conscious qualities, an idea called panpsychism. If the latter were true, then as the universe became more complex, consciousness gradually woke up, more fully within it. If the former is true, then consciousness is an exceedingly rare cosmic phenomenon, requiring a fortuitous chain of events and structures, like brains, to exist. Either way, consciousness is a way in which the universe, otherwise governed by simple physics, has something internal, something it feels. Through conscious beings, the universe experiences qualities like color, sound, pain, and love, which otherwise would not exist. A rock orbiting a star doesn't know it's in orbit. A star doesn't know it's shining. But we, conscious entities, do know and appreciate these things. our minds can hold models of stars and galaxies. In a sense, tiny portions of the universe, our minds, have become reflective, able to contemplate the whole. Consciousness also allows the universe to ask questions about meaning and purpose, questions that in a purely material sense might be moot, yet that matter deeply to the conscious creatures themselves. We, for instance, seek purpose in our small lives amid this vast cosmos. Science tells us how we came to be. It doesn't tell us why, if there is a why. Many thinkers suspect that questions like, why does the universe exist? Or, what is the purpose of consciousness? May not have answers in the way we hope. The universe might just be, without deliberate purpose. Yet here we are, imbued with love, curiosity, and longing for meaning. In a way, one might say the universe's purpose, if any, is what we, as parts of the universe, make of it. By our very nature, we invest the cosmos with meaning. When we create art, discover scientific truths, show kindness to one another, those acts give the universe experiences it would not otherwise have. Through us, the cold equations of physics bloom into poetry and empathy. Through us, the universe can admire itself and say, it is beautiful. We humans, so small and temporary, are a way for the cosmos to know itself. We are aware that we are made of star stuff and that we live on a mote of dust suspended in a sunbeam, to borrow a phrase. We've also realized that our minds are the result of billions of years of cosmic and biological evolution, a precious, transient flicker in a very old and vast space. Each of us is a tiny fragment of the universe that for a brief moment is self-aware. And we carry the heritage of the entire cosmos within us. Consider the atoms in your body. The hydrogen in your drinking water was made in the first minutes after the Big Bang. The carbon in your cells was forged in some star billions of years ago. The calcium in your bones was fused in the heart of a massive star and scattered in a supernova. The iron in your blood came from the violent death of a star. The phosphorus enabling your DNA was built in cosmic furnaces as well. We literally embody cosmic history. Stardust runs through our veins. When we look up at the night sky, we are gazing at our kin. The stars are our distant cousins, related by common origin in the Big Bang. The light that reaches our eyes triggers thoughts in our brain, a star's photons, causing a pattern of electrical signals in a mammal's nervous system. How extraordinary that a thermonuclear reactor millions of light years away can set off a spark of thought in a being on Earth. Through those thoughts, the universe is, in a small way, conscious of itself. In fact, when you consider it deeply, there is no sharp separation between us and the universe. We are not observers outside the cosmos. We are an integral part of it. Our bodies are composed of the universe's matter. Our thoughts arise from physical processes in our brains that obey the universe's laws. We emerged from this cosmic system and are immersed in it completely. The universe is our larger body, and we are like its tiny self-aware cells. At this point in the story, the universe, through human minds, can even attempt to summarize its own journey. In doing so, it turns the mirror on itself. We, on our pale blue dot, have reconstructed much of cosmic history. We have mapped the afterglow of the Big Bang. We have observed galaxies across cosmic time and seen back to when the first stars were kindling. We've understood how elements were born in stars and how Earth came to be enriched by them. In short, we have become the historians of the universe, cataloguing its saga. And we are the universe's storytellers too, giving narrative and meaning to events that on their own are neither good nor bad. They simply are. The rise of life, the collapse of a star into a black hole, these just happen, but through conscious eyes, they become stories of wonder, tragedy, and transformation. Now, having journeyed from the beginning of time to speculations about the end, and from the simplest particles to conscious beings, let us conclude with a moment of reflection. Take a slow breath. Feel your lungs fill with air. Much of that air was once inside of stars and will be part of other life after you. Feel your heart beating, a rhythm that connects you to the first heartbeat of the cosmos when it expanded from silence. In this very moment, you are the product of the entire history we've recounted. You are ancient hydrogen and stardust shaped by gravity and chemistry, given form by biological evolution, and endowed with a spark of awareness. The silence that we imagined at the very beginning still echoes within you in the quiet moments between your heartbeats. The darkness that once enveloped the cosmos is the same darkness behind your closed eyelids when you contemplate. But now the silence is filled with the potential for thought, and the darkness can be lit by the imagination. Stardust remembers. The atoms of your body hold memory, not conscious memory, but the record of cosmic events encoded in their existence. Each heavy element remembers a star that lived and died. In a way, when you think about the universe is remembering itself. Your brain's atoms clicking into patterns that mirror the cosmos outside. Time flows through us. We are part of the grand progression of entropy and evolution. The arrow of time that began at the Big Bang runs through every cell in our body. The blood circulating in your veins right now was forged in a sequence of events going back to the beginning of time. You are a wave traveling through the ocean of time, temporarily taking shape as an individual crest before merging back. The universe is not far. It is here. It is in your breath, in your bones, in the light that falls on your eyes. It is the ground beneath you and the space around you. We carry the universe within us, and we walk within the universe. There is no separation. The cosmos is our home and our essence. When the universe speaks, through equations or photons, we can understand because we too are expressions of those same underlying laws. When we cry out in joy or despair, that is the universe, in a small part of itself, experiencing emotion. Our narrative nears its end, but the universe's narrative continues, unfinished. The story of the cosmos is still being written, in the motions of galaxies, in the birth of new stars, and perhaps in the endeavors of conscious beings like us. We find ourselves at a wondrous juncture. We can look back and reconstruct much of cosmic history, and we can look forward and ponder cosmic futures, but we are still at the dawn of understanding. There remain deep mysteries, dark matter, dark energy, the origin of it all, the purpose of consciousness, that we have yet to unravel. The universe is unfinished, not just in the temporal sense, with events yet to happen, but in the sense that its truth is not yet fully known. There are pages left to read, and perhaps new pages still to be written by the acts of intelligences. If we last long enough to spread life beyond Earth, for example, we will be adding a new chapter to the universe's story. We end where we began, in darkness and stillness. Picture the void before creation once more, that expectant nothingness. Picture the stillness after a possible end, the quiet of a heat-dead cosmos, or the silence of a post-Big Crunch void. In some sense, they are the same silence. The universe may end in silence as it began in silence. But between those two silences, what a symphony of being has played out. A symphony with movements of blazing brilliance, the era of stars, and deep recesses of melancholy, the cold depths of space, with themes that intertwine matter and energy, creation and destruction, simplicity and complexity. We have been part of that symphony, a brief, delicate violin solo in a grand orchestra. Without us, it would still be magnificent, but with us, it can be appreciated from within. We are the universe listening to its own music, even as we play our small part. The narrative pauses now, but it does not truly stop. Even as these words cease, stars will continue to shine and atoms will continue to collide in the vast reaches of space. The universe goes on, ever unfolding. And you, a child of the stars, go on as well, carrying the knowledge and awe gleaned from this story. When you next step outside on a clear night, perhaps you will feel more connected to those distant points of light, knowing what they are and how they came to be. Perhaps you will sense, as ancient stargazers did, that the universe is not a cold stranger, but a deeply related entity, our ancestor, our substance, our home. Listen, in the quiet night, under the cosmic ocean of stars, you can almost hear it, the heartbeat of the universe. It is the blood pulsing in your ears, and the echo of gravitations and vibrations that ripple through space. It is the memory of the Big Bang imprinted in your very atoms, and the faint music of all the stars carrying on through the dark. In that soundless music is a truth felt, if rarely spoken. The universe is alive in us, and we are alive in the universe. We are not mere observers, we are participants. Its story is our story. Its beginning is our beginning, and its future, though unknown, is tied to us as well, for we are part of this cosmos. The tale of the universe is thus far a tale with no known ending, an unfinished book, an open-ended quest. We find ourselves on one shining page of that epic, aware of our role and eager to read on. The universe is, forever, unfinished, an ever-unfolding mystery in which we, for a fleeting moment, get to partake. And in that fact lies profound hope and meaning. The song of the universe goes on, and we, conscious flecks of stardust, get to harmonize with it, adding our verse to the cosmic chorus. The story continues, and we are part of it, always. It is unfinished.